Traveling to space costs a fortune, but there's a way to make it affordable. You step into an elevator, push the button, and voila! You're flying to the stars, all thanks to nanotubes. But then something hits the elevator on the way. You're stuck inside, and now you're doomed to float in space forever. Now, if you want to travel in space, get ready to shell out around $55 million. But in the near future, you'll probably be able to travel to space with just the push of a button without breaking the bank, because space elevators might come into play. While the idea of galactic lifts seems like something out of a sci-fi movie, it is a real possibility that could revolutionize space travel. With an estimated cost of $8 billion, space elevators could be a one-time investment that would last us forever. NASA alone spends around $2.7 million on rocket fuel per minute. To launch a rocket, they need to pay up to $178 million. These costs could be significantly reduced with the use of elevators. Most super tall buildings on Earth have a massive foundation to help with their balance and weight. As you look up, they get thinner and thinner. Even the tallest building in the world, the Burj Khalifa, is massive at the bottom and narrow at the top. If we wanted to construct something like a gigantic lift, we would need an enormous amount of concrete to build a foundation for it, which goes against the point of saving some cash. Now, get a string, tie a ball at the end of it, and start spinning it. The string in your hand will stay in one place, and the ball will revolve around your hand. This is called centrifugal force, and the elevator will work in the same way. The ball will be the base in space, and the rope will hang toward Earth. The station from where we would enter the elevator would be in the middle of the Atlantic Ocean, and the line would extend from there. For this to be possible, the line must be perfectly synchronized with Earth's rotation. Otherwise, it would simply break or wrap around the Earth like a scarf. Also, the orbit the line would be following should be a perfect circle, because the line wouldn't be able to get shorter or extend. A bunch of research has been done using algebra to find the ideal solution. Wait a second, there's a use for algebra? Never mind. Meanwhile, I won't bore you with the math. We'll go straight to the point where the precise distance from the station in the Atlantic to the one in space must be 22,236 miles above the Earth, where the geosynchronous orbit starts. There, the four outward forces are much stronger than the downward force. That's why the station would stay in one place. When you construct a house or a building, you start from the bottom going up. But to create this engineering wonder, we would need to do everything in reverse and start at the top. The main problem here would be the weight. If the line was too heavy, it would disrupt the orbit, and the conveyor dumbwaiter host would not work. So, we need to balance the station in space to ensure it worked flawlessly. Steel is one of the most robust materials on Earth. The cable in every lift is made from steel. But when you need a 22,236-mile-long cable, things can get tricky. Steel is hard to break, but it's cumbersome, and when you have to use a lot of it, problems start to arise. We use heavy steel a lot in construction, but we have lighter materials that might put less stress on the station and eliminate this problem. Also, the line would have to be tapered because, at the endpoint, there would be close to zero stress. But it would still have to be thicker than really needed due to a bunch of safety factors. At the start, the rope would be around 0.5 inches. After using some complicated math, we can figure out the thickness at the end, which is a number so long I am unable to pronounce it. But believe me, it's a big one. So, steel is off the list. Another candidate is Kevlar, which is 5 times stronger than steel. And if we added such materials as carbon and titanium into the mix, the strength would increase tenfold. The line would have a diameter of around 262 to 557 feet. This is drastically smaller than the diameter of the steel cable could be. The bad news is that doing this is too pricey. So, if we don't find the ideal medium to build a cable, the idea of the space elevator will just be a massive waste of time. If only we had some magically light material with a power of 60 gigapascals, which would have a taper ratio of 1.6. Oh wait, we actually do have this unique material. It's called carbon nanotube. It has a strength of 130 gigapascals, which is much more than we need. Nanotubes are made out of carbon and are 100,000 times thinner than a human hair. This material is solid and has good conductive power, which is possible thanks to its unique atomic structure. We use this product in many things, from batteries to optics, and it can be modified entirely and adapted for more uses. Bradley Edwards is the guy responsible for this crazy idea. NASA was looking for new innovations, and they said, "Don't do anything too crazy and start building a space hoist." I guess Bradley took this as a challenge and started working on the elevator. Edwards wrote a paper about a galactic conveyor. When he published it, he expected many people to find flaws in his work, but surprisingly, nobody did. His work was spot on. He came up with the idea of strapping a nanotube line to a rocket and launching it into space. The other end of the rope would fall onto Earth, and robots would use this rope to climb up and make it longer, so we could start building an elevator space station. After this, the elevator could start transporting everything, from solar panels to tourists. In the future, space tourism could be totally possible. Who knows? We might even go on vacations in space. Hey, looking for some atmosphere for your getaway? Well, don't come here. We don't have any. Oops, probably not a good advertising slogan, huh? Meanwhile, a couple of years ago, we could only create microscopic carbon nanotubes. But as time went on, much more research was done to make them bigger. Now they reach up to a few inches. In 20 years, they could be miles long. Carbon costs $28 per ounce. If we do the math, we would see that we would need around $1 billion to build a lift. Yeah, it sounds expensive, but it's a long-term solution to space travel, and it can actually save us a lot of money in the long run. Now, everything looks perfect on paper, but NASA's main reason why they chose not to go along with this project is that right now there are probably more than 128 million objects floating in orbit, and they might pose a real threat to the elevator. The lift could be made to withstand a few hits now and then, but getting hammered non-stop is not part of the plan. Still, Bradley argues that tons of monitoring devices track space debris. Thus, the elevator could avoid them all. Now, if something hit the elevator or the line somehow broke, the consequences would not be too bad. If there were no passengers on board, of course. If the line got cut, the elevator would simply float away into space, posing no threat to people on Earth. In Japan, engineers are trying to build a space elevator. The lift could be used for space mining, too. We could easily cover the cost of the entire elevator by collecting asteroids, because some of them are made of expensive metals. We could mine them and quickly bring them back to Earth. Beneath the frozen ground of the northernmost region of Finland lies a discovery with the potential to change the world's future. From nuclear energy to electric cars. These minerals make it feel like a sci-fi future is just around the corner. But, as always, it's not that simple. Let's explore why. All the way up here on the map is a region called Lapland, a land with only one chair for every 2 people, so someone has to sit on someone else's lap. It's a remote snow-covered corner of Finland, where reindeer outnumber people who live there. Here, the night sky glows with the northern lights almost 200 times in a single year. Oh, and Santa Claus has a house there. In 1985, Finland declared that Santa lives in Rovaniemi, a town just south of the Arctic Circle in Lapland. They even built Santa Claus Village, where visitors can meet with them. You can cross the Arctic Circle line and see his main post office, which receives hundreds of thousands of letters from kids worldwide every year. So, it's sufficient to say that most people know about this place because of Santa's workshop, rather than scientific news. But deep below the ice in pine forests is the Sockley deposit. It's a massive mineral geological site that's been studied for decades. It's mostly known for iron and phosphate. We use iron to make, well, almost everything, while phosphate mostly ends up as fertilizer to grow our food. However, recently, surveys revealed rare earth elements, niobium, and traces of radioactive metals like thorium and uranium. The possibility of thorium is what made news outlets excited. Thorium is a naturally occurring, slightly radioactive metal. It's way more common in the Earth's crust than uranium. In fact, it's about 3 to 4 times as abundant. Scientists love it because thorium could be turned into nuclear fuel with huge numbers as the output gain. A chunk of thorium the size of a golf ball could, in theory, generate as much energy as several tons of coal. It also comes with some major perks. Thorium reactors would produce less waste, meaning that thorium is much easier to contain and safer to use. And it even has an interesting trivia. Thorium was once used in old-fashioned gas lantern mantles because it glows when heated. And that's not all. The Sockley deposit also has other rare minerals that are critical for making magnets that go into wind turbines, electric cars, and even your smartphone. With the right investment, this single deposit could help Europe build thousands of new wind turbines or power millions of electric car batteries. So, did Finland and the entire planet just hit the geological lottery? Well, yes and no. Today, nuclear plants don't run on thorium, they run on uranium, the trusty fuel that has been powering reactors for decades. The whole system, from mining to reactor design to handling the waste, is built around uranium. It already provides around 10% of the world's electricity. In fact, in some countries, like France, it's the main source. It works, it powers millions of homes, and the industry knows exactly how to handle it. Thorium does not play by the same rules. It's not fissile, which means it cannot split and release energy on its own. Which is a fancy way of saying it needs a little help to become useful. You cannot just toss it into a regular reactor and expect magic to happen. That would be like trying to charge a Tesla by pouring gasoline into the tank. To make thorium work, you'd need different types of reactors and the system that could support them. One that's expensive, experimental, and not yet ready for prime time. So yes, Sockley's thorium looks impressive. It's full of sparkle and promise. But for now, it is staying underground, waiting for future technologies and investments. But what about those other rare earth elements? Neodymium and praseodymium might be tricky to pronounce, yes they are. But they're hiding inside almost everything these days, from earbuds to the massive MRI machines in hospitals. They drive the motors in electric cars and help giant wind turbines spin. In short, they're everywhere. And then there's niobium. This metal makes steel even stronger. Add a little niobium and suddenly you've got stronger, lighter alloys used in bridges and even rockets. Today, Europe imports nearly all of it, mainly from Brazil. If Sockley were developed, Finland could give Europe a homegrown supply. However, again, it's complicated. Like I mentioned, Lapland happens to be one of the most beautiful places on the entire planet. It's one of Europe's last great wildernesses, where pine forests stretch for miles. And digging up all those materials wouldn't be without consequences. Mining at this scale could ruin the landscape, upset Santa, or endanger delicate Arctic ecosystems. After all, we're talking about radioactive elements. It's not just about nature, though. Indigenous Sami communities live in Lapland, so they have a voice in what happens. It's a tricky situation that relies on more research and tech advancements. Until then, what are some other delicate places that could hide thorium? Well, thorium is not that hard to find. It's tucked away in beach sands and mountain deposits. But the coolest place to get it would be from the moon. Back in the 1990s, NASA's Lunar Prospector spacecraft mapped the lunar surface and spotted areas unusually rich in thorium. Now, that's an incentive for speeding up the future moon missions, especially since our satellite probably hides elements like helium-3, which are incredibly rare on our planet. Mining the moon might be a perfect solution. Big companies will certainly have way less competition. But hey, that sounds like a decent challenge for humanity, given that the moon has no atmosphere, which makes it exposed to radiation and wild temperature changes. So, we will see. Meanwhile, let's go back to Earth for another seemingly unrelated discovery. Going down to the deep ocean seabeds, scientists recently found something pretty surprising. While exploring the Pacific abyssal plains, they discovered polymetallic nodules. These are potato-sized lumps of metal that are also important for making batteries. But the cool part is that the nodules seem to be releasing oxygen into the water. Scientists call it the dark oxygen. Normally, oxygen comes from photosynthesis, which needs sunlight to reach plants, algae, or bacteria. But down here, in total darkness, there is no sunlight. The idea is that these rocks act like tiny batteries. Their surfaces can create very small electric currents and split water into hydrogen and oxygen. Basically, these rocks might be quietly breathing oxygen all on their own. If this is true, it could change how we understand deep-sea life. Some creatures might not just rely on hydrothermal vents or food falling from above. They could be getting a secret oxygen boost from the rocks themselves. Now, research is still new, and some researchers say this oxygen could be contaminated or just too little in volume to matter. But if it's real, it means life in the abyss might have a secret oxygen supply we never even knew existed. Creepy, mysterious, and kind of amazing all at once. It also makes us wonder about life on other planets. If rocks on Earth can make oxygen in total darkness, maybe extraterrestrial oceans on moons like Europa or Enceladus can too. The universe might be full of secret oxygen factories just waiting to surprise us. Finally, aside from thorium, Finland recently made headlines with another cool geological discovery. Scientists found some zircon crystals that washed into rivers, and when they looked closer, they noticed that the chemical signatures didn't match local rocks. Instead, they traced back to Greenland. This suggests that part of Scandinavia's ancient base might actually have come from there. In simpler terms, it's possible that Scandinavia broke off from Greenland and drifted across the ocean billions of years ago. This unexpected link makes the Nordic landscape a lot older and more interesting than we previously thought. Whether the Sokley deposit could power the future with infinite energy remains to be seen. Each day seems to bring another discovery that inspires conversation and prompts us to learn something new. Who knows what new technologies or hidden resources the next decade will uncover? Now, excuse me, since I've learned his address, I have to write a letter to Santa. I'm still trying to get off of his naughty list. This catapult-like system on the moon might bring us limitless energy. It's a launch system concept that was recently proposed by the Chinese scientists. It would work like a hammer throw, spinning a launch arm that flings objects. This arm is supposed to be about 165 feet long. It will accelerate until it reaches the moon's escape velocity, and then whoosh, the capsule is sent into space. This crazy idea will cost around $18 billion. Ooh, pricey. But trust me, it's totally going to be worth it. The system would be powered by solar panels and nuclear energy. It could also recover more than 70% of the energy used after each launch. The moon has a very weak gravity. There's also barely any atmosphere, so the air doesn't weigh you down. This makes it so much easier to launch stuff there. But why do we even need this? The main purpose is to transport helium-3. It's a really cool isotope of helium, and one of the most insane things about it is that it could become fuel for nuclear fission. This is the same process that happens in stars, including our Sun. If we manage to recreate nuclear fusion here, on Earth, we can make it a clean and basically limitless source of energy for power plants. But helium-3 is super rare on Earth. We can sometimes find it in volcanic rock formations on the ocean floor. That's because it's a product of another rare element called tritium, the element we usually make in nuclear reactors and put in cool stuff like glow-in-the-dark paint. But the catch of tritium is that it takes forever to decay and turn into helium-3. Now, there's a bunch of helium-3 on the moon, around 1 million tons. Just 20 tons of helium-3 could meet China's yearly electricity needs. In fact, lunar soil has enough helium-3 to power the entire world for over 1,000 years. But why is there so much of helium-3 on the Moon and barely none on our planet? Well, that's because helium-3 comes from the sun and travels in solar winds. Solar winds are like streams of dangerous particles. They're super radioactive. Our planet's thick atmosphere and magnetic field serve as a shield for us. They almost fully protect us from those particles. But, unfortunately, they also prevent the good stuff like helium-3 from getting here. The Moon's atmospheric shields are super thin though, so it's under a constant shower of solar winds. So, helium-3 accumulated there over billions of years, and now it's just scattered around there. But mining it and bringing back to Earth is no easy feat. It's super expensive. Just think about it. Rockets need tons of fuel to break free from gravity. Every single bolt and screw on the spacecraft must be engineered to survive extreme conditions, like radiation. Not to mention, you need a team of rocket scientists, literally working around the clock to make sure nothing goes wrong. You can't call a repair guy if something breaks on the Moon. So generally, it costs about $500,000 to send 1 pound of payload to our satellite. That's based on estimates from NASA. To get some idea, let's calculate how much it would cost to send an apple to the Moon. A typical apple weighs about 0.4 pounds, so that funny mission would be at least $200,000. Now, for comparison, the Chinese launch system weighs around 80 tons. Another problem is that the lunar surface is pretty harsh on the equipment, like the freakish lunar dust, for example. You might recall this small thing that happened in the 60s called the moon landings. But when the Apollo astronauts came back from the Moon, they found something weird was happening to them. Their throats were sore and their eyes wandered. Luckily, it wasn't some scary moon sickness. Turns out, there's a lot of lunar dust clinging to their spacesuits. This dust seems harmless, but it's made up of sharp and abrasive particles, much smaller than a human hair, yet sharp like glass. It contains silicate, a thing that can cause severe lung problems on Earth and is a common issue for miners. So it caused a lunar hay fever. At least that's how NASA astronaut Harrison Schmitt called it. All 12 astronauts who walked on the Moon were then sneezing and experiencing nasal congestion. Sometimes it took days to fade away. The dust even got inside their spacecraft, smelling like burnt gunpowder. This nasty stuff can be harmful to both humans and equipment. It managed to damage spacesuit boots and even ruin the seals on the containers used to bring back samples during the Apollo missions. As we mentioned, they're glass-sharp and jagged, so they start scratching, grinding, and wearing down any surfaces they come in contact with. They don't care if it's metal, glass, or humans. And since there's so much dust, this causes equipment to malfunction and fail quite quickly. And that's just one of the possible hurdles with lunar missions. So scientists really need to come up with some weird ideas to get that precious helium-3. The Chinese scientist project looks like a weird sci-fi invention, but it's a cost-effective way to transport materials back to us. It could throw stuff to Earth twice a day, and it would be 90% cheaper than current methods. Since it only needs electricity and no fuel, the system would be small and easy to set up. Besides the beloved helium-3, this catapult would also help advance technologies in space mining and heavy launch vehicles. No lunar dust scares this thing. It should last for at least 20 years. It would need to be transported to the Moon using China's super heavy lift rocket. But the idea is far from new. There was a novel called The Moon is a Harsh Mistress by Robert A. Heinlein. In the story, there's a lunar colony that uses an electromagnetic catapult to send weed and water ice back to Earth. It gets quite wild when the colonists, known as loonies, eventually take control of this catapult. They threaten to launch rocks at Earth unless their colony is recognized as an independent world. Sounds kind of funny, but a large rock, if thrown at us from the Moon, could wipe out a city. The damage would be like from a meteorite strike, with fires, houses destroyed, and worse. But scientists have been talking about this catapult idea for a while. For decades, they were trying to find a way to use electromagnetic systems to send resources from the Moon to Earth. There are also some challenges. For example, scientists forgot to mention how exactly helium-3 would be extracted from the lunar soil. Installing this launch system on the moon's rugged surface would be difficult as well. Also, they would need to make sure that the system remains stable at high speeds and that it could withstand the moon's extreme temperature changes, cosmic rays, and intense solar radiation. So, it would take some time to develop. China hopes to have the key components of the system ready by 2030. The full-scale operations might start by 2045. China has tons of plans for the moon. For example, they want to build a research station at its south pole by 2035. But China's not the only one in this space race. Considering that NASA plans to send humans on Mars by that time, oh boy, the 2030s will be a crazy decade for space exploration. There's also an American startup that's part of the lunar economy. The ones that plan to land astronauts on the moon have people actually living on our satellite in a decade or two. One of the goals of this colony is to boost economic growth and create new jobs. Most of them will likely involve some mining activities. And if there'd be 2 space colonies, well, they'll have to figure something out. Do you know that our planet has scars? One of them is located in North America. This scar can tell us many cool things about the history of Earth, but the most interesting thing is that it could change the appearance of our continents and break our world. But for some reason, this scar hasn't done it yet. And that's not even the most interesting part. The coolest thing about this scar is that it might hold a giant source of clean, cheap energy. So let's go to Kansas to find out what it is. So, 1.1 billion years ago, a giant rift formed in the crust of our planet on the territory of the modern U.S. Midwest. It's called Broken Heart. This giant crevice is filled with solidified magma, and from afar, it looks like a real scar. But how did it show up? Broken Heart was an ancient rift valley, a huge geological fault forming elongated hollows in the Earth's crust. It occurred because tectonic plates had moved apart. It's like the details of a jigsaw puzzle that suddenly started to separate. At that moment, thousands and even millions of tons of magma spilled out from the depths of our planet. That event looked like a real apocalypse, lasting about 100,000 years. But then it stopped, and scientists don't know why. If the rifting process had lasted longer, then most likely, the continent of North America would look different today, or it wouldn't even exist at all. Right now, this fault looks like a giant horseshoe that stretches from Kansas north to Lake Superior and south to Michigan. But some studies indicate that the fault may be larger and extend even further south, and the width of the fault might equal the width of the Red Sea. After the rifting stopped, the entire valley got covered with hills and trees. The fault itself is covered with a thick layer of sedimentary rocks, so it's quite difficult to track. The most noticeable parts of the rift are in the Lake Superior area. Now everything looks calm and beautiful, but in the past, there were fountains and rivers of lava, earthquakes, a boiling pot on a planetary scale. All that remains of it are deposits of basalt, a dark, dense rock that forms from cooled lava. There was so much basalt that its weight pushed the valley deeper and deeper into the Earth's crust. Even when the eruptions and rifting stopped, the valley continued to sink because of the huge mass of this sediment. Then, massive sections of the Earth's crust on both sides of the valley began to contract, and the pieces of the puzzle slowly started to come together. This led to a large-scale ejection of volcanic material upward, and along with basalt, deposits of copper rock appeared in the valley. People mined this copper for about 8,000 years until the end of the 20th century. The copper mines were eventually shut down, but now it seems the industry is making a comeback. However, Broken Heart is not interesting to people just because of its copper reserves. It holds something more valuable and useful for our civilization. Scientists believe that this valley hides massive reserves of hydrogen, and this substance can help us switch to a cleaner, cheaper, and more efficient energy source. If hydrogen fuel becomes widely available, everyone will switch to it, leaving behind the costly, noisy, and polluting process of oil production. Now, I'll bet hydrogen is a remarkably familiar word to you. It doesn't sound like the discovery of the century, and people have been using it for a long time. On one hand, you're right, but not quite. 90% of the hydrogen produced by humans is used as a raw material for the chemical industry. Hydrogen is used to produce ammonia for fertilizers, methanol for fuel and solvents, and to purify crude oil. Manufacturers of glass, cement, steel, and other metals are considering using hydrogen at their factories for more efficient production. Hydrogen can become an alternative to fossil fuels, that is, oil and gasoline produced from them. Cars, ships, trains, airplanes, and power plants, all of these may switch to hydrogen soon. In this case, production can become cheaper and better for nature. But this will work only if we find open sources of hydrogen. You see, about 95% of the hydrogen we use is produced from fossil fuels. We gasify coal, oxidize hydrocarbons, and extract hydrogen from methane. All of these production methods require energy. But the worst part is that they lead to large emissions of carbon dioxide into the atmosphere. But what if we find sources of pure hydrogen that don't require processing? Then we'll save energy for its production and make the planet cleaner. But where can we find such sources? Scientists say that there are many of them all over the planet, and one of the largest is located in the Rift Valley in the U.S. Midwest. But what's the problem with going and mining it? Well, it's not that simple. To extract pure hydrogen, you need 3 conditions. The first is the source of hydrogen itself, which is quite logical. The second is reservoir rocks, that is, natural containers where this hydrogen is stored. And the third is natural seals, which prevent the gas from escaping. In other words, these seals work like a cap on a bottle. They don't allow the substance to escape. So in general, it's necessary to find where hydrogen is released, where it accumulates, and where it's stored. When these conditions are met, natural resource extraction companies can start working. But how does hydrogen appear altogether? Well, let's go over the basics of chemistry. Hydrogen and oxygen compounds form water. This means you need to split the water into hydrogen and oxygen. This process often occurs in nature. There are many places all over the planet where this happens. Scientists are confident that at least 30 U.S. states have hydrogen reservoirs, and if people detect them, we will accelerate the energy transition to safer and more efficient fuels. Thousands of cars drive around using gasoline. Many of you know the smell of exhaust fumes, that thick polluted air that's hard to breathe. What about electric cars? They must be improving the situation, right? Well, here's another problem. Producing batteries for these vehicles harms nature. The materials used to make batteries are lithium, cobalt, and nickel. Their extraction involves a large release of toxic materials, not only into the air but also into the water. Transporting these batteries also creates a large carbon footprint. Producing a single electric car emits about 4 tons of carbon dioxide. To make up for that, the owner needs to drive it for at least 8 years. That's how long it takes to offset the emissions a regular car would produce. What about reliability and convenience? What will you do if the battery runs out during the trip and there are no charging stations nearby? This problem will be solved in the future with the growing popularity of electric cars. Now, scientists believe that over the past billion years, the Earth's crust has split enough water into hydrogen and oxygen. Our planet keeps this gas in the ground, waiting for us to start using it. According to calculations, even considering all the technologies and production capacities of our civilization, the reserves of hydrogen in the bowels of the planet are enough to supply us with energy for 170,000 years. That's why the giant rift in Kansas attracts scientists from all over the world. Huge quantities of basalt and other rocks can react with water to release hydrogen. And now scientists are looking for places where this material accumulates and is stored. Pretty soon, you'll be able to charge your phone in your pocket while walking around the house. And meanwhile, Your electric car will refuel while just standing in your driveway. Power will run to all your gadgets through the air without any wires whatsoever. I know it sounds a bit sci-fi, but scientists have figured out how to do it. Don't worry, they're not going to zap electricity through the air like lightning. Instead, they'll use something much safer: magnetic fields. Let's say you have a special coil of wire that makes a magnetic field when it gets power. If you bring another coil close to it, that second coil absorbs the energy and turns it into electricity. That means you can power things without plugging them in, like a light bulb that turns on all by itself. And according to scientists at the World Health Organization, these magnetic fields are completely safe. Now, I suspect you've already used an early version of wireless electricity. When you place your electric toothbrush on its charger or the phone on the charging mat, electric energy jumps between them. There's a special coil inside the charger that creates an invisible spinning energy field when it gets electricity from the wall. The toothbrush or phone has another coil inside it that catches this energy and turns it back into electricity to charge the battery. This is called electromagnetic induction, but this method only works for short distances and wouldn't be useful for powering your entire house. Some companies are already working to make this technology perfect and accessible. One company has invented their method to send power through the air called air cord. They use it in real-life products. One cool example is tiny video screens placed next to products in supermarkets with changing images. These screens don't need batteries or power cords. Another gadget that's running on this tech is a smart lock designed by the same company. Normally, smart electronic locks need powerful batteries, but this one stays powered without a battery and gets energy from a wide-charge transmitter in the ceiling. That transmitter is like an invisible power outlet. It works similarly to a TV remote, where you use an infrared beam to control the gadget from a distance. In this case, the transmitter takes electricity and sends it to all gadgets that need power as an infrared beam. The transmitter analyzes each device to see how much power it needs, just like a Wi-Fi router manages the internet for different devices. If no devices need power, the transmitter goes to sleep, but it wakes up now and then to check if anything needs charging. Nikola Tesla, a brilliant inventor and electrical engineer who made significant contributions to the development of electricity, would be really happy to see all this come true. He believed he could build a system that would transmit electricity and communication signals through the Earth's ionosphere all over the world. To prove his idea, he built a special Wardenclyffe Tower in New York. His plan was to use the Earth itself like a giant electrical circuit. In 1899, Tesla traveled to Colorado Springs, known for its big thunderstorms. He built a lab there to test his wireless electricity ideas. The high altitude and frequent lightning storms made it the perfect place for his experiments. Then he returned to New York, and with money from a wealthy investor, he started building the Wardenclyffe Tower. Tesla placed iron rods and copper plates under the tower to help send power through the Earth. There would be a huge metal dome on top of the tower. By 1902, the tower and lab were mostly built, but Tesla ran into funding problems. The Wardenclyffe Tower never worked as Tesla had hoped, and in 1917, it was torn down and sold for scrap. In any case, Tesla's idea only worked for short distances. The farther the electricity had to travel, the weaker it became. Scientists needed a way to send energy over long distances, and they found two viable solutions in the middle of the 20th century: microwaves and lasers. In 1964, engineer William C. Brown flew a tiny helicopter for 10 hours using only microwave power. Then, in 1975, Brown and a NASA scientist, Richard Dickinson, sent 30,000 watts of power over a mile using a research station called Venus. But there was still a problem. Half of the power was lost before it reached its destination. Over the years, technology kept improving. Computers, lasers, solar panels, and transistors became more advanced and opened new horizons for wireless electricity. It could eventually help us switch to cleaner energy from fossil fuels like coal and gas. New Zealand-based company Emrod uses power beaming technology that starts with electricity from the power grid and turns it into microwaves. These microwaves travel through the air from a sending antenna to a receiving antenna, which turns them back into electricity that we can use. But there's a problem. Various kinds of waves work in different ways. Microwaves can travel long distances without losing much power, which makes them great for sending energy to remote islands or factories. But if you try to send microwaves all the way from space, you'd need a receiver the size of a city. Lasers can make the energy beam smaller and more focused, which means the receiver can also be tiny. But lasers can be blocked by things like clouds, fog, or dust. Right now, power beaming won't replace power lines over huge distances, but it could be used for smaller projects like charging flying taxis and delivery drones in the sky, powering robots in cities and factories, and replacing backup generators during emergencies. Countries all over the world are investing in power beaming. Europe is focused on clean energy. The Japanese Space Agency hopes to have a giant solar power station orbiting Earth, collecting sunlight and beaming electricity down to us by the 2030s. This space station could send 1 gigawatt of energy, as much as a big nuclear power plant produces in a year. The space power station is still a work in progress, but the technology is getting better and cheaper. So, in the future, we might have a world where there are no more tangled wires, no more ugly power lines, and even free electricity for everyone. Japanese scientists are now working on another groundbreaking tech, a special machine that can turn sunlight and water into hydrogen fuel. This clean energy source could one day power cars, homes, and even entire cities. The current reactor is as big as a small house. It works by using photocatalytic sheets, which act like tiny solar panels that absorb sunlight and trigger a chemical reaction. This process splits water molecules into oxygen and hydrogen. It allows the hydrogen to be collected and used as fuel. Right now, the process isn't efficient enough to produce hydrogen on a large scale. Most existing methods of making hydrogen still rely on fossil fuels. But the scientists behind this new reactor found a better way. Instead of breaking water apart all at once, which wastes energy, their machine does it in 2 steps. First, it separates oxygen, then it collects hydrogen to make the process smoother and more effective. The team used a special photocatalyst that responds to UV light, and they found that under natural sunlight, the solar energy conversion efficiency was 1.5 times higher than in the lab. In some places with stronger sunlight, the efficiency could be even greater. But still, at its current stage, the reactor only reaches about 1% efficiency, which is far too low for commercial use. Scientists believe that for this technology to become practical, they need to increase efficiency to at least 5%. To make this happen, they need better photocatalysts and larger reactors, and they would also need to find safe ways to handle a tricky byproduct, which is a highly flammable gas created during the process. But if they can boost efficiency, many scientists and companies will start mass-producing this technology, leading to clean, renewable hydrogen energy on a large scale.
Recently, Chinese scientists discovered something interesting on the Moon, an unusual crystal. Moreover, they found out that this crystal contains an element that can literally replace nuclear fuel. Let's find out more. The composition of the Moon has long remained a mystery to us. Half a century has already passed since the Apollo mission. Unfortunately, we haven't traveled to the Moon much since then. So it's not surprising that it's not so easy for us to study it. But recently, we've made a breakthrough in this area. In December 2020, Chinese scientists sent the Chang'e 5 probe to the Moon. The mission was named after the ancient Chinese deity of the Moon, Chang'e. Quite poetic, isn't it? Anyway, after the probe went to the nearest side of the Moon, it spent several days digging through the surface and rocks, and then returned to Earth. In total, it collected about 4 pounds of various lunar rocks, like basalt, solidified lava, and so on. And yeah, maybe it doesn't sound too impressive, but it's actually a mini breakthrough. After all, we hadn't received any lunar samples since 1976. And these samples are very important for learning the history of our world. We've been struggling for many years to find out, for example, how the moon was born at all. Yes, there were a lot of theories, but we still couldn't find any proper evidence for any of them. But thanks to the latest missions and some computer simulations, scientists finally found out the truth. The moon was born when some random dwarf planet crashed into our Earth many millions of years ago. This dwarf planet was slightly smaller than Mars. The fragments of the Earth went into space, but some of them stayed in our orbit. Then they stuck together and formed the moon. It sounds horrifying, but in reality, the birth of the moon was the best thing to ever happen to our planet. If it weren't for this beautiful satellite, all our oceans would be small puddles. Life wouldn't have appeared on Earth at all. So this is already an amazing discovery, but that's still not all. Studying the collected rocks, scientists from the Beijing Research Institute discovered something unusual. A rare lunar crystal. Looks pretty boring, doesn't it? Just some tiny transparent monocrystal about the thickness of a human hair. We've already found such things on the moon before. These crystals were formed as a result of volcanic activity, just like some garnets on the Earth. And yep, the place where they discovered these crystals also suffered from volcanoes 1.2 billion years ago. That means that this tiny baby is over 1 billion years old. But that's not the most important thing. It's the fact that this crystal is made of a unique material, the one that we've never seen before. Researchers from the International Mineralogical Association have confirmed that such a composition can't be found anywhere on Earth. The crystal was named Chongasite, again after the same moon deity. And this is another achievement. This is the 6th previously unknown mineral that we've found on the moon and the first one found by China. Now, it has become the 3rd country in the world to make such a lunar discovery. However, this tiny crystal still wasn't the only remarkable thing they found. After studying this gem and about 140,000 other lunar particles, scientists have discovered something else. They found helium-3. Why is it so important? Because this is one of the elements that feed the sun and other stars in our universe. We tend to say stuff like, put out the sun is burning, and so on. And this is one of the reasons why many people actually think that the sun is a huge fireball. But it's not. Its burning is actually a completely different process, which is called nuclear fusion. The process itself is quite simple. During this reaction, hydrogen in the star turns into helium. But this simple process is actually one of the most violent and insane reactions in the universe. There's a real boiling broth of particles inside the sun. The hydrogen nuclei that jump and rush there are constantly repelling each other since all of them are positively charged. And so they could continue to boil and chill around without bothering anyone if it weren't for the stars. The stars turned out to be cheaters. They have such strong gravity that they basically grab billions of these little atoms and squeeze them together. Combining with each other, these atoms create new heavy elements, like the mentioned helium. And when this happens, they throw a lot of energy into space. And that's how the sun burns. At the same time, it spreads so much energy that we can't even imagine. Okay, so what is helium-3? Well, this is an element to which even the sun can say, "Whoa dude, you should calm down." The fusion of helium-3 atoms releases even more energy than in typical nuclear fusion. And most importantly, it doesn't pollute the atmosphere with harmful things like radiation. We have very, very little helium-3 on Earth. Its prevalence in our atmosphere is about 1 in a million. And besides, it's constantly trying to escape from us back into space. Probably feels some bad vibes from us. However, scientists have recently found out that there's a place that contains a lot of this element. Yep, You guessed it, it's the moon. We think that there's more helium-3 on the moon than on Earth because of the solar winds. The sun has been hammering on the moon with its helium-3 for billions of years, so now it's all over the place. It's still not too much if you compare it, for example, with Jupiter or Saturn. But don't forget how much energy it can release. For your information, with only 25 tons of helium-3, it's possible to provide America with energy for an entire year. Now, there are 35,000 tons of it here on Earth, and more than 1 million tons on the moon. Only these sources could feed the entire US for thousands of years. So basically, in the future, helium-3 may become a new source of fuel. And it's better than nuclear fuel in basically everything. Helium-3 won't leave any harmful waste and radiation. It's more powerful and not that dangerous. In other words, this environmentally friendly and efficient energy could be a revolution for our planet. Sounds cool, huh? So, what are we waiting for? Grab the shovels, you might say. But there's a little problem here. Unfortunately, we haven't yet come up with anything as wildly strong and hot as the stars. To use helium-3, we need crazy temperatures and pressure. We need a thermonuclear reactor, and we have no idea how to build it, yet. And even if we could heat it up to such temperatures and get the needed pressure, we still don't really know how to handle helium-3 correctly. Therefore, even if we have an infinite amount of helium-3, we still won't be able to use it. But still, there's a great power behind helium-3, so it's not surprising that different countries have already started a race for nuclear resources. Now that Chang'e 5 has discovered a new helium-3 deposit on the nearest side of the moon, this race can become downright global. For example, China already plans a new lunar mission in 2024, Chang'e 6. During this mission, they want to collect the first samples from the far side of the moon. As you can see, finding this lunar crystal was very important for us. These crystals can help us find new ways to create helium-3. And if we manage to do that, humankind will enter a new era. But to do this, we still have to solve a number of problems. How to deliver a bunch of these lunar crystals to Earth, how to make them produce energy, and so on. Let's hope that in the future these issues will be resolved and we'll find a way to produce clean, safe, unlimited energy.
There's a country that runs on volcanoes, rivers, and lakes for power. Sounds like a fantasy game setting, but it's all true. Welcome to New Zealand. This island nation already gets about 85% of its electricity from renewable resources like hydro, geothermal, and wind. That's impressive, but it's actually just getting started. Now, let's zoom in on a place called the South Taranaki Bight. It's a stretch of sea off the west coast of the North Island. At first glance, it looks just like any other tropical postcard location, but it's hiding New Zealand's clean energy jackpot. It's all about the South Taranaki offshore wind project. This game changer in the world of green power will build wind turbines in the ocean, enough to generate almost 1 gigawatt of clean electricity. That's roughly enough to power over 430,000 homes. To put that into perspective, that's almost a quarter of all the households in New Zealand. If the country can pull this off, it won't just become greener. It'll kickstart an entirely new profitable industry: offshore wind. It means over 600 new jobs in construction, operations, and maintenance. And these jobs are future-proof. The kind that won't disappear as the world moves away from oil and gas. It also means more tech development for the country, and of course, more energy independence. Experts also believe it will secure more business investment in New Zealand, and the entire offshore wind sector should bring in around $30 billion to the country's GDP between now and 2050. The South Taranaki Bight is a perfect location for this project. It gets consistent, powerful winds, not stormy and chaotic, but steady and useful. That's exactly what you want for wind turbines. And the seabed here is deep, but not too deep, which is ideal for turbine platforms. They usually build traditional wind turbines on land or in shallow water where they can stand on firm foundations. But the ones planned here are offshore wind turbines, which means engineers can install them in deeper water, further from land, and in stronger wind zones. The electricity the turbines generate will move to a major onshore connection point through cables. From there, it will travel via national grid infrastructure to power homes, businesses, and industry. To make all this happen, the project team has already laid the groundwork. One of the coolest things they've done so far is a floating LiDAR campaign. LiDAR means light detection and ranging. And it's like radar, but with lasers. They put this high-tech gear on a floating buoy that stays in the ocean for months. It collects crazy precise data about wind speeds, wave patterns, sea temperature, currents. That's all the stuff you need to plan an offshore power plant. If the project works out, it will take New Zealand to a new green level. Right now, the country still uses fossil fuels during peak demand times or when the hydro lakes run low. Most of those fossil fuels come from overseas, and they're expensive, polluting, and unreliable. But if offshore wind goes big, it could plug those energy gaps, especially during winter when winds are stronger and electricity use spikes. And if New Zealand produces more clean energy than it needs, it could start exporting it as green hydrogen. It's hydrogen made from water using renewable electricity, which is really healthy for our planet. The South Taranaki offshore wind project, if all goes well, will be more than a local win. It'll be a blueprint, a model other regions of New Zealand could follow. There are wind-rich areas all around the country's coastline, and floating offshore technology makes them more accessible than ever. Some scientists believe New Zealand could build up to 8 gigawatts of offshore wind by 2050. That's 8 times what's being planned in Taranaki right now. Imagine what that could do. Clean energy for the whole country, plus exports, plus global leadership in a brand new industry. Of course, it's not all smooth sailing, and there are some challenges on the way. First, there's marine life. Any large ocean project needs to be careful about how it affects whales, dolphins, fish, and seabirds. That's why scientists are studying marine baseline in the early planning stages to map out the local ecosystem and avoid any harm to it. They've already started this process in the Taranaki Bight and are gathering information so turbines can be placed where they'll do the least damage. There's also a high cost. Offshore wind is more expensive than onshore right now, but costs are dropping as the tech improves and scales up. Plus, the long-term benefits, cleaner air, local jobs, energy security, make it worth it. And then there are potential problems with authorities, local tribes, iwi, and the community. They all must support the project for it to become a reality, and it's not always working out. For example, when a 34-page review article about the risks of the wind farms for the environment came out, local authorities were reviewing it. But if everything goes well, construction in the South Taranaki Bight could begin in the late 2020s. Iceland is a great example of a country where green, renewable energy works and rules. 9 out of 10 homes in this country stay warm thanks to underground geothermal heat. Thanks to its wild geology with volcanoes, hot springs, and glaciers, Iceland is packed with natural energy. It sits right on a super active part of the Earth's crust, where 2 tectonic plates meet. That's why it has so much geothermal power and hot water just bubbles up from below. Glaciers cover 11% of the country, and when they melt in the warmer months, they feed rivers that flow down from the mountains. That water's energy is turned into hydropower. Plus, Iceland also has lots of wind power potential. They just haven't tapped into it much yet. The only major thing still using fossil fuels in Iceland is transport, like cars and planes. But it wasn't always this way. Not long ago, Iceland relied mostly on imported oil and coal, especially before the 1970s. Back then, they mostly used geothermal energy for bathing and washing clothes. The change came when oil prices went up like crazy, and Iceland realized importing fuel was just too risky and expensive. the country needed its own stable, affordable energy. One farmer figured out how to use natural hot water to heat his home. Local communities followed his lead, and soon towns were drilling deeper underground to get even hotter water. That hot water then went through pipes around neighborhoods and heated entire towns. It worked so well that the authorities set up a special fund to give out loans for geothermal drilling. Others started building small hydro plants. By 1950, Iceland had over 500 tiny hydropower stations powering farms and villages. Later, the authorities stepped in again to attract big international companies. If Iceland could offer cheap green power, maybe new industries would move in, create jobs, and help grow the economy. That plan worked, and it also helped build a country-wide power grid. And it was all possible, not just because Iceland has amazing natural resources, but also thanks to teamwork of the authorities and regular citizens. A lot of countries today face the same problems. Nepal, for example, has tons of hydropower potential, but needs investment. Countries in East Africa have loads of underground geothermal energy, but not enough training or tech to use it. Iceland has been sharing what they know for decades. Since 1979, over 1,000 people from other countries have gone there to study geothermal energy. Icelandic companies have helped build geothermal systems in more than 50 countries, including the world's biggest one in China, which now heats homes for over 1 million people. And you don't even need volcanoes to use geothermal energy. New technology means you can use lower temperatures to heat and cool buildings. Paris, for example, has one of Europe's largest geothermal heating systems. Around 25% of Europeans live in places where this tech could work.
Wouldn't it be really cool if we could collect energy from space and bring it down to our planet? That means we wouldn't need to get electricity from wind, water, or other resources available on Earth. Millions of people would charge their phones, store food in the fridge, watch TV, and do so much more thanks to electricity we'd get wirelessly from space. It kinda sounds too good to be true at first, but this idea isn't science fiction anymore. Not only is it possible, but we might see it sooner than we think, maybe even by 2040. SEI is short for Space Energy Initiative. They're currently working on an exciting project called Cassiopeia, and its main goal is to place a constellation of big satellites in a high orbit of our planet. Once the satellites are in their spots, we're likely to get access to big supplies of solar energy. Almost unlimited, some would say. We can get 40 times more energy from solar panels in space than from those located on Earth. Space is enormous. There's enough room for all those solar power satellites in our orbit, and each of them will be able to generate as much electricity as we get from a power station. If this worked out, we would be able to convert this energy to microwave energy. This type is similar to high-frequency radio waves you can find in a regular microwave oven. Then, we transmit it down to our planet and use it in everyday life. We'd need many antennas all over Earth to do this, of course. They would pick up the beams so that energy could be transformed into electricity in the end. Scientists are going to get millions of dollars to try out these space-based solar power projects, SBSP. These satellites will consist of hundreds of thousands of tiny identical pieces produced in our factories. The cool part is that we will have robots that will put them together. Scientists will program them to work on their own without any help. These robots will also service and maintain satellites when necessary. Of course, using solar energy isn't a new thing. It's an important resource for humankind right now as well, but it's not the same level as having solar panels in space. It's different because our atmosphere diffuses sunlight. In space, we will get this energy directly from the sun. Nothing will interfere with the process. Microwaves can easily go through clouds in our atmosphere. Also, sunlight in space is available at all times, so you can get energy not only during the day. Plus, the light is more intense up there than it is after it goes through all the layers of our atmosphere. Scientists from the UK are currently working on this project, but teams from all over the world want to develop and set up these space-based solar panels everywhere so people across the globe can benefit from them. They're working on this project in the US too. Scientists have already tried out a new thing called a sandwich tile. They used it to transform solar energy into radio waves. Microwave beams do sound like something dangerous when you first think about it. But scientists have tested them and found out that they are efficient and also very safe for wildlife on our planet and us. They tested this principle on a small scale first. They beamed microwaves from one point to another, and the distance between these points was 110 feet. A microwave beam is like a Wi-Fi we have all over the planet. It's not very intense, approximately a quarter of this intensity of the midday sun. This idea is not new. Scientists have been considering it for over 50 years, but it was too expensive and too complicated to implement because we didn't have technologies good enough to do that. But now it seems possible. The study where they'll test it will take 3 years, and the goal is to see if these large solar farms we want to build in space can really work. Another question is if we will be able to get them at a reasonable price too. The sun is an awesome source of clean energy, and we might get even more energy than we can consume now or will consume in the future. To get solar energy from space, we need solar panels. Inflatable mirrors or reflectors will collect sunlight and direct it onto those panels. Then they will beam solar energy onto Earth. If this works out, solar energy will top all the other sources of energy combined. So, why don't we have solar panels in space already? It's expensive, okay, but there's also a high risk of space debris or radiation damaging these solar panels. Another risk is that we're likely to lose too much energy while transporting it back to Earth. So many new exciting space discoveries have been made over the past few years. For example, a super-Earth we discovered in 2017. It's an exoplanet, which means it orbits a star that's not in our solar system. And a super-Earth is a term we use to describe a planet more massive than Earth, but also lighter than ice giants, such as Uranus and Neptune. A super-Earth can be made of rock, gas, or a mix of both. It can be up to 10 times Earth's mass and twice its size. This cool super-Earth we found several years ago is 21 light-years away from us. It makes a full circle around its parent star, which is an M-dwarf star, in just 2 weeks. So that's how long a year lasts there. I don't even want to think about how old I'd be there. Wouldn't mind more presents, though. There are some planets out there that could harbor life, too. One of them, also discovered in 2017, could be the closest one to us where there's a possibility of life. This year, scientists found another super-Earth. It's 40% bigger than our home planet and closer to its star than we are. But its sun is over 6 times smaller than ours, and its temperature is twice as low. We don't even have to travel far to find new things. There's so much we don't know about our own solar system. We've discovered a new moon orbiting the biggest planet in our solar system, Jupiter. Jupiter is gigantic, which means its gravity is very strong and attracts many space objects. Take a look at our home planet. It has 1 moon. Mars has 2. And there are at least 79 moons orbiting Jupiter. I mean, there are probably hundreds of moons we have yet to discover. The new one circles around Jupiter in the opposite direction of Jupiter's rotation, and it's positioned at an extreme tilt relative to Jupiter's orbital plane. And we have some work to do in our own neighborhood too. NASA will go back to Venus by 2030. The last time scientists launched a mission there was in 1989. The reason why no one continued exploring Venus is probably that people are talking about going to Mars most of the time. Researchers have discovered something called phosphine in Venus's atmosphere. This element is special because on Earth, only the activity of humans and microbes produces it. So there could be some forms of life on Venus. There could have been a world with rivers and oceans on this planet a long time ago, before its surface became hot enough to literally melt lead. You can't talk about discovering new things in space and not mention at least one black hole. This newly found one, called the Unicorn, is only 1,500 light-years away from us in the constellation of Monoceros. That makes it the closest to Earth black hole that we know about, and scientists found it when they noticed the light of its companion star become brighter. They understood that something was tugging on that star, even though they couldn't see the black hole directly.
So a few years ago, in 2019, folks in Australia said they liked an old idea with a new twist, using extra floodwater from the north to help dry areas in the west and south. This plan got the name of the New Brainfield Scheme. It was based on an old idea from the 1930s. The idea was to catch floodwater from the north and move it to the south and west. But the original plan never actually happened. Over the years, lots of experts said it wouldn't work. They thought it was too expensive and too tricky to build, even though it could potentially help fix drought problems in dry parts of Queensland. The original idea appeared a long time ago, when an engineer named John Brainfield got a big idea. He wanted to take floodwater from rivers in northern Queensland and send it inland to Lake Erie, one of the driest spots in Australia. He planned to use dams, pumps, really big pipes, and even tunnels to transport all that water over the Great Dividing Range, a big mountain range in Australia. The biggest dam would have been called Hell's Gate, and Brainfield wanted it twice as tall as what it was originally planned. This way, pumps and gravity could help move the water over the Great Dividing Range. The water would then flow south and help irrigate farmland near places like Hughenden. It would change the weather, make it rain more, and turn the dry land into green farms. Eventually, it would reach Lake Erie, turning the desert into a green growing area. That way, Australia could grow more food, sell it to other countries, and make more jobs. He hoped that the area could turn into a food bowl for the country. For some time, people talked about the plan a lot. They loved the idea. They thought it could change how farming worked. And some even believed that nature had already planned for the land to be filled with water. Dry rivers and lake beds were just waiting to be used. They even said that rains fell on the wrong side of the mountains, and Brainfield's plan could fix that. But when the authorities looked into this idea, they found big problems, and the main one was that the plan would cost too much. Plus, there weren't enough scientists or engineers to do a full investigation. The land was too dry and harsh. No one was sure it would even work, like how much water would really get there. Plus, some of Brainfield's measurements were wrong, especially the dam heights. So, in 1947, they officially shut the project down, claiming that even if they built the project, it wouldn't be worth it. After all, even places next to oceans, like parts of Chile, still stay bone dry, so a big lake might not result in more rain. And still, in 2019, one political party brought the idea back with an updated version called the New Brainfield Scheme. They wanted to try it again, but with some changes to make it work better. Their plan included the following steps. Take water from the South Johnstone, Tully, Herbert, and Burdekin rivers. Store that water using a big dam called Hell's Gate Dam, but this time they wanted to make the dam twice as tall as in the original plan. Let the water flow through tunnels using gravity instead of using lots of pumps. Move the water under the mountains and into the Warrego River in southern Queensland. Use the water to grow crops in dry places south and west of Hughenden, a huge area even bigger than Tasmania, eventually turning it into a food bowl. At the same time, they didn't say how much the whole project would cost. But they promised to spend $20 million to let Australia's National Science Agency check if the plan could work. Those innovative ideas sounded good, but for over 80 years, loads of experts kept saying, "Nope, it won't work." Why? Branfield said his idea would cost £40 million back in 1941. That's about $3.2 billion today. But the new version of the plan might cost more than $15 billion and take over 10 years to build. Also, people who care about nature are worried. They explain that taking water away from where it usually goes could hurt animals and plants. It might let invasive plants and animals spread to new places. It might mess up rivers and oceans, where fish and other animals live. It could even hurt towns and businesses near the coast that depend on those natural water flows. Still, some people really believed in the idea and thought it was worth doing, especially to help farmers and fix drought problems. However, in 2022, the government decided to stop trying to fix the drought in western Queensland with the Branfield scheme. Experts looked closely at the plan and said it just wouldn't work. The problem? There's not enough water all the time to make it happen. Apparently, the new cost of the plan would have been over $30 billion. That's a huge amount of money. You could buy yourself a fleet of private jets and luxurious yachts, and more. So experts said you'd need lots and lots of water to spend that kind of money, but the water just isn't there. Now, instead of one huge project, they suggested doing smaller water projects closer to where the rain and waterfalls are. These smaller projects, called mini Branfield grids, would be in 4 places along the Queensland coast. Those little grids could share water when some places had more or less rain. Other scientists looked at the plan too, and they agreed. Even if things went super well, the Branfield scheme would still cause problems and cost way too much, while the mini water grids project looks more plausible. They think the dry parts west of the mountains will do better without the full-scale Branfield scheme. There are easier and cheaper ways to help those places grow and get water. So the big plan was dropped, and now they're looking at smarter, smaller ideas to help with water and farming. And the matter is quite urgent. Australia is a super dry place, one of the driest places people actually live in. When there's a drought, there's not much water around. That means farms don't grow as much food, and that can cause a lot of problems. In the future, droughts are likely to happen more often and be worse. That's why it's necessary to start getting ready now. Experts are working on something called the Drought Resilience Mission, trying to figure out how to deal with droughts better in the future. One of them looked at how much droughts actually cost Australia. His research shows that droughts can hurt a lot of things – farms, jobs, towns, and even the whole country. When there's no rain for a really long time, some towns can actually run out of water. That's called day zero. It's when the taps in people's houses get turned off because there's just no water left. In 2020, a town in Queensland called Stanthorpe hit day zero. About 50 other towns were really close too. When such a situation happens, the only way to get water is by bringing it in with trucks, and that's super expensive. Stanthorpe had to get around 20 trucks of water every day for a year and a half. It cost them about $800,000 every month. In the end, they spent over $14 million just to have water. Luckily, it started raining again and filled the dams back up. But the authorities are working on ways to stop this kind of thing from happening again. They want to help towns be ready so they never run out of water like that. Because drought just doesn't mess with water, it can also mess with people's health. When everything dries up, plants vanish and the soil gets loose. Then the wind picks it up and makes huge dust storms. Those dust clouds can blow really far, even into such big cities as Sydney. That's what happened in 2018. The air got so bad that kids, older people, and anyone with breathing problems had to be extremely careful. The dust ruined some crops and made different foods, even fruit, unsafe to eat.
Closing the North Sea in a nearly 400-mile-long dam may save Europe from complete disaster. This is not some sci-fi stuff. It's real. And it's called NEED, Northern European Enclosure Dam. It's a last-ditch plan to save over 25 million people from 15 European countries from the rising sea levels. To build this giant bathtub, humans need one dam between England and France, another one between Norway and Scotland, 51 billion tons of sand, and almost 600 billion euros. As crazy as it may sound, this project is totally feasible, except for one teeny tiny detail. The scientists who had this literally life-saving idea don't want the dam to be built. First and foremost, the needs two dams. One that is 100 miles long and almost 334 feet deep in the English Channel, and another that is 300 miles long and more than 1,000 feet deep in the North Sea. Building something like this requires a crazy amount of materials, like the 51 billion tons of sand we mentioned before, which is basically all the sand everyone on the planet uses in a year. And yes, this dam would obviously be the biggest in history, smashing records like the Netherlands' 19-mile Afsluitdijk and South Korea's 20-mile Saemangam seawall. The Need Dam would be 19 times bigger than Saemangam. It sounds ridiculous, but it's not impossible. You see, humans are pretty good at building big stuff. Oil rigs, for example, operate at depths of up to 6,500 feet, and the Need Dam would only go down more than 1,000 feet. Plus, China has a 102-mile-long bridge, and the dam would only be 4 times longer. Besides, projects like this dam were done before for the exact same reason. It's our friend Afsluitdijk in the Netherlands, which was built almost 100 years ago. The idea here was to shut off a part of the North Sea called Zuiderzee and protect the Netherlands from all the flooding because most of the country is below sea level. They even drained one of the lakes formed by the dam and created a whole new province, Flevoland. Today, the Netherlands has more than 2,200 miles of flood protection, but it's only designed for a 15-inch sea level rise. Without it, the country would be underwater. So yeah, we could do it, but it's really, really expensive. How expensive? Well, it would cost around 550 billion euros if the project is wrapped up in about 20 years. One wrong step and humans can spend 100 years building this dam, and a couple of billion euros more. The good news is that this much money can be diluted over the 20 to 100 years it takes for the dam to get finished. Besides, the 15 countries it would protect could share the expenses, reducing the amount to only 0.1% of the GDP of all the countries. Not a bad deal to save millions of people, right? Okay, but is this monstrosity really necessary? Well, unfortunately, humans have managed to turn the ocean against us. This means that by 2100, the sea levels are expected to have risen between 1 to 2 feet. If we keep acting like it's none of our business, the rise can reach more than 16 feet by 2300. It may sound like a distant future, but NASA has just discovered that the ocean rose way more than they expected in 2024, which means global disaster is breathing down our necks as we speak. Let's go back to our geography classes for a moment and learn why sea levels are rising altogether. First, because land can sink. The city of Norfolk, Virginia, for example, was built inside a massive crater, and the earth there can erode and sink. Then the soil can get compacted. Because of that, the city is literally sinking into the ground, making it more vulnerable to flooding. In California, some areas are sinking too, but this time it's because of the movement of tectonic plates. Some of the land that is underwater goes up, some of the land over the water goes down. The consequences? Again, heavy flooding. Sea levels also rise if the planet gets too hot. This happens because of a thing called thermal expansion. It has a very scientific name, but it basically means that things like water get bigger if the temperature rises. Half of the reason why sea levels are rising is because of this. This is why the level of the ocean increases almost 10 feet every time the average temperature of the planet rises by 33.8 degrees Fahrenheit. Since 1880, the sea has risen more than 8 inches. Okay, so we build the Need Dam and the problem is solved, right? Well, building this dam comes with massive consequences. First, the ocean currents, think of them as underwater highways that deliver nutrients to tiny creatures like planktons, not the SpongeBob villain, and give rides to animals like lizards and tortoises. A dam this big is capable of messing up the ocean currents that bathe Europe, disrupting the food chain not just inside the dam, but outside too. The currents are also responsible for the climate of coastal areas. The Gulf Stream, for example, is a warm current that comes all the way from Mexico and makes the weather in northwestern Europe a bit more bearable. If the Gulf Stream got interrupted by a gigantic oceanic barrier, it could make parts of Europe even colder. Another problem is that the North Sea would turn into a gigantic freshwater lake. This would happen because the salt water that used to flow from the ocean would now be blocked. And the North Sea would only be fed by the fresh water coming from inside the continent. This process would eventually lead to a thing called desalination, when salt water gets less salty. And it's really terrible because saltwater animals would start to absorb more water than they should, making the cells of their bodies swell. The consequences can be fatal. The disruption of the ocean currents by the dam can also affect the renewal of oxygen in the water. Think of the ocean as a giant recycling system. Surface water needs to sink to deliver oxygen to the deep sea, keeping creatures dwelling at the bottom alive. Without the movement of ocean currents, oxygen would run out and toxic bacteria would take over, creating a poisonous environment for sea creatures. And this is not just a theory. It happened before, 250 million years ago. The ocean got so toxic, it wiped out 95% of marine life and caused a mass extinction. If it's not bad enough, the fishing industry would collapse, and the busiest trading ports of Europe like Rotterdam, Antwerp, and Hamburg would be stuck inside the dam. Sure, we could build sluice gates, but imagine all those traffic jams. The rain patterns of the countries protected by the dam would change too, affecting farming lands and food production. On the other hand, if we do nothing about rising sea levels, permanent flooding could make whole countries disappear. 3 million people on the islands of the Pacific would need to move away by the end of the century. The Maldives would lose 77% of its territories, and cities like Jakarta, Bangladesh, and Lagos would go underwater. Storms would get more dangerous too, destroying treatment plants for sewage and power stations and contaminating farmlands. Rising salt water could also contaminate freshwater supplies, and it's not just happening in Asia and Europe. Philadelphia, for example, is already developing plans to deal with this bleak scenario. This is why the scientists who developed this big red button shaped like a dam don't want people to actually build a dam. They know how bad things can get, which is why they came up with a plan so wild it's basically the engineering version of screaming, "Hey, stop ignoring the planet!" It's a warning. If we don't act now, we'll be stuck building mega dams just to keep our cities from becoming Atlantis 2.0. And let's be honest, nobody wants to live in a future where the apocalypse looks like the deep web version of The Little Mermaid.
Our planet has 5 oceans: the Pacific, Atlantic, Indian, Southern, and Arctic, not counting Billy Ocean. But it seems there's a 6th one out there too. It's just that you can't see it. Scientists have found evidence of large amounts of water hidden in the transition zone. That's the boundary layer that separates the upper and lower mantle of our planet. That boundary goes hundreds of miles deep down below the surface. Natural diamonds usually form in the mantle, but at depths of up to 155 miles. Some of them are very rare. They may come from deeper depths. That was the case with this fascinating diamond that formed 410 miles below the surface. The gem was big enough for scientists to study it and determine what it was made of. They were surprised when the composition of this very rare diamond showed that it was formed in pretty watery conditions. Because of that, such a diamond wouldn't be worth much in jewelry stores, but it was priceless in the lab. So, could this mean there's an ocean under the surface of our planet? It would definitely get us closer to the idea Jules Verne had about this whole magical secret world inside Earth, including the ocean. But that's not exactly the case. The water is there, true, But it's not like you can enjoy the view watching waves splashing around like on the surface of our planet. The water is actually stored within the minerals. That's why this area is so wet. Let's now move to Africa to keep up with the story, or to be more specific, to a spot called the Afar region. It's part of Ethiopia and a place where three tectonic plates meet. Tectonic plates are large pieces of our planet's crust that slowly move. These movements cause earthquakes and produce volcanoes, mountains, deep underwater valleys we call trenches, and so on. And the Afar Valley is where the Arabian, Somali, and Nubian plates meet. Together, they form an intersection in the shape of a Y. Why? Let me tell you. These plates are moving all the time. The Somali plate is moving southeast toward the Australian and Indian plates. The Arabian plate is moving north, getting closer to the Eurasian plate. At some point, it will close the Persian Gulf. This movement of plates has created something we call the Great Rift Valley, considering there are, all these cool rifts. The Aden Ridge to the east, the Red Sea Rift to the west, the Oculus Rift and the East African Rift to the south. But the East African Rift is something we want to focus on, because this one could be the key to this potential sixth ocean, but this time on the surface. A continental rift is a spot where two tectonic plates that form a single continent start to separate. Here it's the Somali and Nubian plates. Together, they're parts that make up Africa. If they keep moving in separate directions, this currently continental rift may become what we call an oceanic spreading ridge. In other words, when the plates are far enough apart from each other, there will be an enormous crack between them. This way, magma will freely flow up from beneath them. It'll be cool and eventually start creating a new ocean floor. Africa will be split into two parts, and there will be a new ocean flowing between what will turn into two mini-continents. Nope, it's not time to get your swim trunks and sunscreen yet. Even if the Somali and Arabian plates do move far enough to form an oceanic spreading ridge, it'll take millions of years before this happens. So I guess it's more interesting to stick to exploring this sixth ocean below the Earth's surface for now. The idea of subsurface oceans goes beyond the borders of our planet. It's possible many moons and planets out there have them too. Our home planet is the only one we know about with consistent bodies of liquid water on the surface, true. In our solar system, we circle around the Sun in something called the habitable zone. The temperature and atmospheric pressure within this zone allow water to remain in liquid form all the time. But a couple of moons in our solar system could also contain significant amounts of water under their surface. Enceladus, one of Saturn's moons, is the first one. Enceladus is a small frozen ball, 7 times smaller in diameter than our moon, but it's the 6th biggest moon of Saturn. Nearly a decade ago, a spacecraft found evidence that there was a large ocean under its surface. It found and sampled water from the eruptions that resembled geysers. A geyser is a rare type of hot spring that erupts and sends jets of steam and water into the air. Like Old Faithful in Yellowstone? Well, this water was erupting through fissures in the ice at the south pole of the moon. That means there might be a liquid ocean under the thick layers of ice. The ocean there is almost nothing like ours. The ocean on Earth is relatively shallow, on average 2.2 miles deep, and it covers 3/4 of our planet's surface. It gets colder the closer you come to the seafloor, and is warmer if you stay close to the surface because of the sun's rays. But the subsurface ocean on Enceladus is at least 18 miles deep. It's cooler at the top because that part is near the ice shell, and warmer at the bottom because of the heat coming from the moon's core. But both our ocean and the ocean on Enceladus are salty. Enceladus is one of the few places in our solar system that has liquid water, which makes it an interesting spot to search for signs of life. Another one is Europa, one of Jupiter's moons. Scientists think similar eruptions of water could be happening there. Knowing there are such geysers there tells us these moons have their own source of energy. Maybe the energy that makes the water erupt comes from gravity or radiation. The same energy could keep a large body of liquid water under the ice. It could even support some forms of life. There are thousands of planets beyond our solar system that orbit other stars. Some are even in the habitable zone. Over a quarter of the ones that we know about could have liquid water, but the majority of them probably have oceans under their surface, like Enceladus and Europa. Pluto might be on this list too, since it's possible it hides a liquid ocean under its thick frozen shell. This subsurface ocean likely formed long after the dwarf planet did, after the heat coming from radioactive elements in Pluto's core melted some of its ice. There's also something called water worlds. Those are moons or planets with global oceans that are more common than we thought. I mean, some call Earth a water world too. 71% of its surface is water after all. And when you look at our home planet from space, you mostly get those blue marble pictures. When exploring other planets, especially those outside of our solar system, researchers often go with a policy of follow the water. After all, water is the main element we know that's necessary for supporting life. And when there's a water world that's close to its parent star, scientists assume it must have formed way farther and then moved closer once its orbit shrank. The composition of the planet was set when it was in a colder orbit, or, in other words, when it made a wider circle around its star. We call the process of orbital shrinking a migration, and if water worlds are really that common, it can be proof that migration really happens. Exoplanets are all those planets that orbit around other stars, not our Sun. Some exoplanets may have oceans that are way deeper than any of those in our solar system, hundreds or even thousands of miles deep. Our Mariana Trench is scary, and it's not even 7 miles deep. And those exoplanet oceans are, wow, almost bottomless.
Some places don't look important until the world realizes they hold the keys to the future. That's the case with Canada's Arctic. For most of history, it was just ice, snow, rocks, caribou, and even more ice. But now, it's about to become one of the most important places on Earth, and maybe make Canada a global superpower. Why? Because it's hiding minerals that power electric vehicles, satellites, and missile systems, while the demand is skyrocketing. However, it's not just mining and having resources, it's also about control. Right now, China has a massive head start because it refines over 90% of the world's rare earths. That means if you want to launch a satellite, manufacture advanced electronics, or even just keep the lights on in your fancy smart home, odds are you're relying on China. And that makes a lot of world powers very nervous. Because when everything's going electric, the last thing you need is being dependent on your geopolitical rival. So now, the global clean tech treasure hunt is officially on. The US, Europe, Japan, Australia, they're all competing. However, the latest technology and untapped potential might give Canada the upper hand. Canada's had these minerals for decades, but with low prices, tough terrain, and no global rush, they mostly stayed untouched. However, Ottawa is finally stepping up its game. Back in 2022, Canada rolled out the Critical Minerals Strategy with billions in funding and tax perks to get companies digging. There's also plans to build the necessary roads, ports, and power lines to tap into those remote deposits up north. Canada already produces more than 60 minerals and metals, but 31 of them are now considered critical. 6 of those are having VIP treatment: lithium, graphite, nickel, cobalt, copper, and rare earth elements. But digging it up is just step 1. The real plan? Keep it local. Melt that frozen treasure into shiny new batteries right at home. That means not just mines, but also refineries, processing centers, and high-tech factories popping up where there used to be nothing but snowdrifts and silence. While others are talking, Canada's busy paving roads and stringing power lines. Slowly but surely, they're turning snowfields into a high-tech playground. Getting to all that buried treasure used to be nearly impossible. After all, we're talking about land so remote that roads literally stop hundreds of miles too early. The ground is frozen solid for most of the year. And even if you found something valuable, just getting out was a logistical nightmare. So what changed? Canada has an ace up its sleeve. Don't know about you, but I use it mainly for making memes and music. But geologists, they're scanning the Arctic like it's Minecraft with X-ray vision. Instead of drilling blind, they're using decades-old core samples, plugging them into AI and getting shockingly accurate predictions about what's underground. It's like upgrading from a pirate's treasure map to a GPS that actually says, "Dig here." Companies like Geologic AI and Cobalt Metals are already doing this, pouring data into AI and getting X marks the spot hits for nickel, cobalt, and rare earths. In the Northwest Territories, Canada is running a pilot lab that uses AI and digital scanning to reanalyze decades-old rock samples. The goal is to spot hidden mineral deposits that old methods might have missed without digging a single new hole. All that sounds great, but maybe I made it sound simpler than it is. Digging up the Arctic is a logistical nightmare. For starters, this isn't just a remote patch of land. The Canadian Arctic is huge. Almost half the country, stretching over Yukon, the Northwest Territories, and Nunavut. We're talking about a region larger than India, with fewer people than a small city. Most of it is permafrost, wilderness, or ice-covered islands scattered across the Arctic archipelago. Temperatures go from barely 50 degrees Fahrenheit during summer to negative 40 degrees Fahrenheit or colder, with ground that stays frozen for most of the year. Fun fact, did you know that negative 40 degrees happens to be the same as negative 40 degrees Celsius? It's the one temperature where both scales intersect. They climb at different rates, but eventually cross paths when it gets cold enough. Just a small trivia nugget for weather nerds like me. Anyways, you can't just roll in a truck and break ground in the Arctic. Up there, roads just stop. Want to build something? It can take years, and one nasty winter can put everything on ice. And if you want to continue up north, you need more of everything. More food, more fuel, more machines, which means even more money. Speaking of money, another chilling fact is how much this all costs. Mining in the far north is way more expensive than doing it in, say, Australia or Chile. An AI might tell you where the minerals are, but people and big machines still have to dig, and that costs a fortune. But that's not all. Most of the Canadian North is Indigenous land. First Nations, Inuit, and Métis communities have lived there for thousands of years, and mineral hotspots often sit right on their ancestral grounds. So when Canada talks about unlocking the Arctic, it's not just a question of roads and robots. It's a question of partnership and collaboration. And that's not optional. Legally, projects on Indigenous land require consultation and, in many cases, consent. The good news, some communities aren't just involved, they're leading the way. In regions like Nunavut and the Northwest Territories, Indigenous-owned corporations and world powers are already shaping how development happens on their terms. If Canada wants to pull this off, it's going to need more than tech and funding. It's going to need trust. So with all that in mind, can Canada pull this off? Honestly? With technological advancements and partnerships, it doesn't seem impossible. But Canada isn't just doing one thing right. It's doing a bunch of things at the same time. Let's recap. Hidden resources? Checked. New strategy? In place. Big funding? Approved. AI tools? Deployed. Indigenous partnerships? Underway. Infrastructure? Already breaking ground. It's a snowball turning into an avalanche. Exploration boosts investment. Investment speeds up roads. Roads unlock more deposits. More deposits attract more factories. It's a feedback loop, and if they keep feeding it, the whole Arctic operation could go from an idea to empire faster than anyone expects, giving a whole new meaning to the phrase frozen assets. But this doesn't just help Canada. It could save the US a whole lot of trouble. If all goes to plan, the US won't need to ship rare earths halfway across the planet. It can just look north, wave at the caribou, and get what it needs from its closest neighbor. That's why the US has publicly backed the effort, offering support and funding to help build a trusted North American supply chain. For Canada, this could be the moment it stops being just a supplier of raw materials and starts becoming a critical power broker in the clean tech economy. For the US, it's like discovering your neighbor has been secretly building a battery factory in their backyard while you were building electric vehicles. And globally? Well, the abundance of resources tends to lower the prices, and that's always a good thing for us regular people. Cheaper cobalt, nickel, and lithium mean cheaper batteries. And cheaper batteries mean more affordable electric vehicles, energy storage, phones, laptops, the works. Now, don't get too excited just yet. Like we said, mining in the Arctic isn't cheap. But in theory, once Canada's clean tech engine is fully up and humming, more supply and shorter supply chains should gradually bring costs down. And it's not just about price tags, it's about stability. Right now, if one country cuts exports or gets caught in politics, everything down the line gets shaky. But with Canada stepping in as a reliable supplier, the global system might get a bit more breathing room. Manufacturers can stop sweating over single points of failure and start building with confidence. Do you know how much gold has been mined by humans throughout history? About 216,000 tons. And 2/3 of this amount was mined after the 1950s. Different countries, different times, thousands of different people involved. But what if you found huge deposits of gold in one place? What if a giant gold ore deposit was discovered? No, not just giant, but super giant. This is exactly what was found in China. A group of geologists discovered about 40 gold veins with about 330 tons of gold ore. But that's not all. 3D modeling has shown that even more gold lies underneath. At a depth of about 9,800 feet, there may be several hundred more tons. In short, there is a chance that they will discover deposits with about 1,100 tons of gold. Can you imagine how much that is? If not, that's about $83 billion. Wow! Experts say that this deposit contains approximately 4.9 ounces per ton of ore. It seems that this is negligible, but in fact, it's a high indicator in gold mining. Usually, 0.35 ounces per ton is awesome. If all calculations turn out to be correct, it will be the largest gold mine in the world, even bigger than the South Deep mine located in South Africa, with its 1,025 tons of gold. Everyone is worried. Everyone is happy. Gold, gold, gold on their minds. Everyone wants gold. Everyone buys gold. Gold is rising in price. Gold is more reliable than Bitcoin and cash. Gold is associated with wealth and luxury. Gold is always a valuable and profitable investment. But hold up. Why is it so? Why do people go crazy over some shiny metal? The fact is that gold has both practical and psychological value. For centuries, gold has represented power, prestige, and wealth in different cultures. It seems we're born in a genetic memory that gold is valuable. Think of how many problems gold has brought to literary heroes and how many gold-related adventures we've seen in movies. Gold makes people happy and greedy, cruel and intimidated. That's why so many people love it. Yes, it glitters, it's beautiful, but it's also practical. Gold doesn't rust, it doesn't corrode, it can be stored for a long time, and it doesn't deteriorate. It's literally a reliable investment. All other savings may lose value because of crises, but gold remains unchanged. The only problem, it can get stolen. In addition to jewelry making, gold is used in electronics, medicine, aerospace, and many other industries. Bitcoin has a value because of the public support of people around the world. Money has value thanks to the support of authorities. Gold has value on its own. It's tangible and visually appealing, and its worth is also supported by people's centuries-old belief in its enduring value. But never let gold cloud your mind. Many people lose their honor and even their minds over it. Avoid this trap. It's just a shiny piece of metal. There are other precious metals in the periodic table: palladium, silver, copper, platinum. Why is gold number 1? Cheaper metals such as copper, iron, lead, and aluminum corrode and rust. Aluminum is also not durable. Platinum and palladium are more expensive than gold, but they're too rare and difficult to mine. You won't make many coins out of them. Silver is softer than gold. It tarnishes, scratches, and deforms. And, well, to be honest, gold is more beautiful. But there is another reason why gold is so expensive. It's quite difficult to get. Gold mining is a very laborious and long process. In movies or documentaries, you might have seen people standing at the mouth of a river, collecting silt and clay, sifting it through gauze and small nets, and finding gold particles there. That's one of the methods for how gold is mined. You have to work hard to get just a few small pieces. How do they find gold? It used to be luck. Someone was walking along the shore and saw something glistening in the water. But today, gold detection methods are much more effective. Geologists know that gold is present in almost all rocks and soil, but its particles are so tiny that they're not visible. But when the concentration of gold is high and noticeable, work begins to extract it. Special geological teams are engaged in searching for these sites. When they discover gold, they drill wells, then take soil samples and decide if there's enough metal to carry out large-scale mining. Production depends on the deposit. If gold is in hard rock, miners drill holes, place dynamite, and detonate it. The explosion breaks the rock into pieces so they can extract the gold. But this is just the beginning of the work. After collecting large pieces of rock, workers take them to factories to extract valuable material. At the first stage, specialists break large pieces of rock into smaller ones. Using crushing machines, they grind the ore into tiny pieces, similar to gravel. This gravel then enters rotating drums filled with steel balls. The drums spin, and the balls grind the gravel into powder under pressure. This mass is then mixed with water and passes through special filters. After that, gold is extracted from the ore using chemical solvents and complex purification systems. It adheres to carbon, then is separated from it, followed by several additional processes, including electrolysis and further purification. At the end, the gold is melted and separated from impurities, then poured into ingots and sent to other plants for further processing. Yes, it's a difficult and time-consuming process, and quite a long one. And it's not always profitable. You can find a deposit of precious metal, but it will be too expensive to extract it, and the amount of gold there won't be enough to make the effort worthwhile. Only 10% of the world's gold deposits contain enough precious material to pay back for its extraction and processing. There are many areas filled with gold. Do you know how many of them are suitable for productive mining? Less than 0.1%. So this is probably another reason why gold is so valuable. But is there any other material that causes a lot of excitement? Oh yes, this material is called liquid gold. And this is helium. That's the gas used to inflate balloons. But this is not its main value. Helium is capable of reaching ultra-low temperatures, is superconducting, and is lightweight. Helium is used in medicine for diagnostics. For example, for magnetic resonance imaging. Helium cools nuclear reactors and maintains rocket fuel temperatures during launch. Divers breathe a mixture of helium and oxygen during deep dives to avoid diseases associated with pressure changes. Helium is crucial for the modern world. Another precious material is graphene. It's not just one of the most durable materials in the world, it's a highly conductive material. Heat and electricity pass through graphene easily, which makes it very promising for the development of what? Considering that graphene is also flexible, water-repellent, non-toxic, and has antibacterial properties, it's suitable for developing everything. Medical equipment, mechanical engineering, electronics, construction, logistics, energy conservation, space and underwater industries, and much more. Scientists believe that graphene has the potential to enable revolutionary new technologies that could change the lives of all people. Something similar happened with silicon, which is actively used to create semiconductors and rechargeable batteries. It's possible that without silicon, we wouldn't have smartphones, laptops, and other electronic devices. graphene may also lead to a new technological leap. When the world switches to renewable sources of energy and uses electric transport, graphene can become technological gold. During tests, graphene batteries have shown that they charge more than 70 times faster than regular ones and last 3 times longer. At the same time, they're cheaper and environmentally friendly. Okay, that sounds cool, but where do we get this graphene? It's obtained from graphite, which lies in the bowels of the Earth. One of the largest graphite deposits is located in South Australia. 200 million tons of high-quality graphite. It sounds like it could be enough for the entire planet.
You are looking at a remarkable idea, for this is the story of the miracle seed.
This massive lake in California is worth $540 billion, as it holds enough lithium to power over 30 trillion iPhones. That's way more than experts predicted, making it one of the biggest lithium reserves ever. This finding could revolutionize the US economy, but a major challenge is still standing in the way. If it's not solved, all that money will stay buried forever. First things first, lithium. This metal is so valuable that people call it white gold, and it's unbelievably light. In fact, it's the lightest solid on Earth at room temperature. It was discovered by a Swedish chemist in 1817, and honestly, since then, we didn't really care much about lithium. This poor metal was ignored for centuries because it didn't seem to have any practical use in everyday life. I mean, sure, it's light, it's white, it's shiny. But what could we actually do with it? At some point, though, another trait of this metal started to stand out: its reactivity. Basically, it bonds really easily with other elements. But that also means something else. It can catch fire in seconds. For example, if you expose it to air, it goes through a wild oxidization reaction, and before you know it, boom! Flames everywhere. This might sound like danger to you, but to scientists, it screamed Eureka! Because being super light and super reactive actually makes it the perfect material for batteries. And you get why that's a big deal nowadays, right? Batteries power almost everything around us, like smartphones, cars, and even small airplanes. Since everyone suddenly wants lithium, demand has skyrocketed, and it's not slowing down anytime soon. Back in 2021, for example, the world produced about 540,000 tons of it. But by 2030, predictions say demand could soar past 3 million tons. And here's the problem: lithium is a finite resource. There are only about 100 lithium mines in the world, mostly in Australia, Chile, and China. Sure, supply is expected to grow, but demand is climbing much faster. That means we could be facing a shortage soon. Lithium mines can keep up with today's demand, but they won't be able to do that for many more years. So that's why finding new lithium reserves today is basically like winning the lottery. In this case, the United States is one of the lucky winners. First, there's the Thacker Pass mine. This spot in Nevada might hold the largest untapped lithium reserves on the planet. To put it in perspective, some estimates say it could supply up to 1/4 of the world's lithium demand. We're talking as much as 40 million tons of this precious metal, and that might be worth over $500 billion. Right there, they'll be extracting lithium from clay. This might be challenging, since this process has never been done on such a huge scale before, but it's doable. A couple of years ago, the United States found another big win in the lithium game: the Salton Sea. This is a huge, shallow lake located in Southern California's Imperial County. At first, they announced that this spot could hold over 3.4 million tons of lithium underground. That would be enough to make more than 375 million batteries for electric vehicles. That was already huge. But then, more recently, specialists realized they had made a mistake. Actually, a good mistake. The amount of lithium there is likely much, much higher. It could hold 18 million tons of it. Now, the Salton Sea is being considered the 5th largest lithium deposit in the world. This could be a real game changer. The United States is betting big on this mineral, hoping it'll help keep the country's economy strong for decades to come. So, Finding this second big source of lithium was a huge relief. It means America is one step closer to relying less on other countries. And, by the way, most of its lithium right now comes from Chile.
We refer to as the Saudi Arabia of lithium.
Of course, California is thrilled about this, seeing it as a potential economic windfall. The region is already being called the Saudi Arabia of lithium, or Lithium Valley, because of its potential to dominate the battery supply chain. And if it works out, it'll be a huge benefit for the state. Apparently, authorities plan to use 80% of the money from lithium extraction for local development and infrastructure. The idea is to upgrade roads, schools, and other public services. That could create a lot of new jobs for Imperial County, which is considered one of California's poorest regions. Big question: if the lithium is hiding under the lake, can they even get it out? Well, yes, at least in theory. There are two main ways companies usually extract lithium. The first is the old-school method, open pit mining, where the rock is dug up, crushed, and processed. That's what they do at Thacker Pass, for example. They use massive hydraulic shovels to dig the metal out of the clay. Then there are evaporation ponds. Here, they pump lithium-rich brine to the surface and let the water evaporate, leaving the metal behind. The problem with both methods is that they use tons of water and can cause a lot of contamination and waste. At the Salton Sea in California, things work a little differently. Instead of giant pits or evaporation ponds, companies are using the area's natural geothermal power to pull it out in a cleaner way. This method is called direct lithium extraction. And here's how it works. Near the lake, there are already 11 geothermal power plants that pump up super hot mineral-rich brine from underground. Normally, that brine is just used to make steam, which spins turbines to generate electricity. But now, companies are figuring out how to pull the lithium out of that same brine before sending it back underground. Since they're already pumping the brine for energy, collecting the lithium doesn't need any extra digging or big ponds. So it avoids most of the water waste and pollution you get with old methods. It's like getting clean energy and battery materials at the same time, but with way less impact on the environment. This method sounds brilliant and totally doable, but it also comes with challenges that won't be easy to overcome. Sure, people call it environmentally friendly, but that's only when you compare it to other ways of getting lithium. This method still raises concerns about water use. People in California are already dealing with shortages, and large-scale lithium extraction could put even more pressure on the region's limited water supply. The Salton Sea itself is shrinking fast. Water levels have dropped by more than 9 feet over the past 25 years. That creates a huge problem. Less water means more exposed lakebed. And the sediments there can contain harmful materials. As the lake shrinks, that exposed lakebed dries out and turns to dust, and that dust doesn't just sit there. The wind picks it up and blows it into the air. Now, the Salton Sea's shrinking shoreline is releasing toxic dust into the air. And that dust has been linked to increasing rates of respiratory problems among local residents. Authorities are already taking steps to reverse the situation by adding water to the dry parts of the Salton Sea. They're filling shallow ponds near the lake to make new wetlands. Their goal is to create a safe habitat for fish and birds, and to help keep that toxic dust under control. Some people worry that digging up all this white gold could make the Salton Sea shrink even faster and undo years of restoration work. For now, studies show geothermal plants only use about 4% of the region's water supply, but researchers still don't know if expanding these operations could end up making the water problem worse. So, what happens next? It's too soon to say, but one thing's for sure, we will need a lot more research to understand what this all means, not just for the Salton Sea, but for the future of the US economy. Roofs fly off like paper, huge trees are yanked from the ground, power lines snap and leave neighborhoods in the dark, streets flood like rivers, homes are left in ruins. That's a hurricane passing through. After the wind calms down, the real mess begins. People stranded, no clean water, destroyed roads. Storms have been picking up for like 5,700 years. And the scariest part is that in the last 20 years, there's been a huge spike. But let's start from the very beginning. This is Belize, a small country on the northeastern coast of Central America. And this is the Great Blue Hole, a huge, deep underwater sinkhole about 410 feet deep and approximately 50 miles off the coast of Belize. It formed around 10,000 years ago when the sea levels rose after the last ice age. A team of scientists arrived in Central America to study mud from way down in the Great Blue. They pulled out a long sample of sediment, which is basically layers of stuff that's settled over time. You might ask, so what? How are tropical storms connected with this sediment? Let's see. Tropical cyclones are big, spinning storms that form over warm ocean water. They pull up heat from the sea and blast it into the sky. And yeah, they can be devastatingly destructive, with super strong winds, heavy rain, and floods from big waves. And mud cores like the one the researchers pulled up are actually records of tropical storms. The sample they pulled up was 98 feet long, which made it the longest ever found in that area. Here's how it works. Every year, 2 thin layers of sediment settle in the hole where the weather is calm. But when a big storm hits, it leaves behind a different, messier layer. So by looking at these layers, scientists could tell how many storms hit that spot over the last 5,700 years. It's like counting tree rings, you know? Anyway, what they found was rather unexpected. It turns out that tropical cyclones had been getting more and more common. The lead researcher said that over the past 6,000 years, there were usually between 4 and 16 tropical storms or hurricanes every 100 years. But just in the last 20 years alone, they found signs of 9 storms in that same little area. That's way more than usual, and it shows how much things are changing. Scientists think there are 2 main reasons why tropical storms have been happening more often. One reason has to do with something called the Intertropical Convergence Zone, or ITCZ. This is an area near the equator where winds from the north and south come together. That spot has low air pressure, lots of moisture, and tons of thunderstorms. Just above it is the part of the Atlantic Ocean where most hurricanes are born. It even has an official name, the Hurricane Main Development Region. Normally, the ITCZ moves north in the summer and south in the winter because of changes in ocean temperatures. But over the past few thousand years, it's slowly been shifting farther and farther south. That's why the area where storms usually start has also moved south. It means storms are now forming and heading toward lower parts of the Atlantic than they used to. The second reason for the recent spike in storms is rising ocean temperatures. Earth has gotten warmer, and the ocean has warmed up too. The warm oceans help make more powerful storms. Such an increase likely means that this part of the world might see a lot more big storms in the future. If things keep going the way they are, scientists think the Caribbean could get hit by as many as 45 tropical storms and hurricanes by the end of this century. That's way more than anything the world has experienced in the last 5,700 years. There are just too many changes in the world that influence the situation. They create the perfect conditions for more storms to form and get really intense really fast. But if you think storms are getting more intense only over the ocean, let me tell you about America. A bunch of really dangerous storms, including tornadoes, dust storms, and wildfires, tore through several states in the Midwest and south of the USA in March 2025. At least 42 people lost their lives, and the scale of the devastation is enormous. What's scary is that most of this destruction didn't happen in the usual Tornado Alley area. Tornado Alley is a nickname for a part of the US where tornadoes happen a lot. It stretches through places like northern Texas, Oklahoma, Kansas, Missouri, parts of Louisiana, Iowa, Nebraska, and even eastern Colorado. But this time, storms hit places like Mississippi, Arkansas, and Alabama. Experts had warned this might happen. At the beginning of 2025, they said that tornadoes could start showing up more often farther east than usual. And that's exactly what's happening. One of their top weather experts said people in the Mississippi and Tennessee valleys should get ready for a rough spring. There are more people living in these areas than in traditional tornado zones, and many of them live in mobile homes or buildings without basements, which puts them at more risk when big storms hit. A tornado is basically a spinning tube of super strong wind that comes down from storm clouds and touches the ground. They can be really dangerous. To figure out how strong a tornado is, scientists use something called the Enhanced Fujita Scale. It goes from EF0, which stands for the weakest tornado, to EF5. Such a tornado is crazy strong, tear your house apart strong. The main question is, why are tornadoes happening more in the east now? In the US, tornado season usually kicks off in March. That's when cold air from Canada bumps into warm, wet air coming up from the Gulf of Mexico. And boom, storms start to form. But this year, things are a bit different. Here's what's going on. There's a big patch of high pressure, basically a chunk of calm, warm air hanging over the southwest. That's keeping things more stable out west, so fewer thunderstorms as well as fewer tornadoes are expected there. So, tornadoes are shifting eastward. Meanwhile, the Gulf of Mexico is super warm this year, and that's helping storms form in the southeastern US. The warm water adds a lot of energy to the atmosphere, which can lead to stronger, more frequent storms in places like Mississippi, Alabama, and Tennessee. Up north, around the Great Lakes and Northeast, it's staying cooler this spring. That means fewer big storms up there, at least for now. Now, let's get back to those devastating March storms. On March 14 and 15, a huge storm system blasted through parts of the central and southern US. This system brought 52 confirmed tornadoes, massive dust storms, and fast-moving wildfires. It all led to almost 1,100 canceled flights. About 150 million people were affected by this natural disaster. Two really strong tornadoes classified as EF4s hit Arkansas. The damage was incredible. One of those tornadoes, which hit a town called Diaz, had winds up to 190 miles per hour. That's insanely fast. For comparison, the average speed of a Formula One car is around 130 to 160 miles per hour. It was the first time in over 25 years that Arkansas got hit by two EF4s on the same day. Experts also recorded wind gusts moving at a speed of over 80 miles per hour in the southern plains. In Texas, dust storms led to fatal car crashes. Wildfires, caused and driven by the strong winds, burned through parts of Texas and Oklahoma. Oklahoma alone had more than 130 fires. So, what's next? Experts think the US could see between 1,300 and 1,450 tornadoes in 2025. That's way more than the usual 1,225. And it's not just about tornadoes. A warmer atmosphere can hold more moisture. That means heavier rains, more flash floods, and even more powerful storms. Basically, the formula is the following. Warmer oceans plus warmer air equals stormy weather, especially in the east and southeast. But even if you don't live in any of these areas, you can't feel completely at ease either. Experts say tornadoes and other natural disasters can happen pretty much anywhere in the US. The risk moves around depending on the time of year and the weather.
So, we just spotted an asteroid so massive it could wipe out an entire continent if it ever hit Earth. And it's moving insanely fast, almost record speed. But what makes it really scary is how it's basically playing hide and seek with us. It can slip right into the sun's glare and vanish completely. And yeah, it just did it again. It disappeared. So, when we finally spot it again, will we have enough time to prepare? Or could it already be too late for humanity? Do I have your attention now? Thanks. So, meet 2025 SC79. That's a mouthful, so I'll just nickname it Scooby. This newly found asteroid is a sneaky one, the kind that loves hiding in the sun's glare. Think of it as trying to spot a firefly next to a stadium light. The brightness hits your eyes and outshines anything faint nearby. So yeah, you won't see that firefly. Now asteroids hide in the same frustrating way. When they end up close to the sun from our point of view on Earth, the glare overwhelms our telescopes, and the asteroid's dim, reflected light gets lost in it. That's why some asteroids can cruise along in the sun's direction and stay basically invisible to us. And scientists say the most dangerous asteroids, the ones that could wipe out a whole city, are the hardest to detect. That's why astronomers need to somehow dodge the sun's glare. One way they do it is by observing the sky during the short window of twilight. Right before sunrise or just after sunset. And that timing is a big deal, because it's the only way to catch some risky asteroid before it sneaks up on Earth. Scientists say that if one of these so-called twilight asteroids ever gets close to Earth, it could be a serious impact threat. And it was during one of these twilight observing sessions that scientists finally spotted this huge asteroid. It was September 27, 2025. Scott Shepard, an astronomer at a Washington-based institute, was scanning the sky, hunting for anything unusual in our solar system. And he had an incredible tool in his hands, the Dark Energy Camera, or DECAM, one of the most powerful sky survey cameras on Earth, built to spot faint objects across huge areas of the universe. At one point, he spotted a faint dot moving across the image, so he quickly aimed the high-tech camera at it, and things got more interesting. Its movement matched what astronomers expect from asteroids that orbit very close to the Sun. Then, follow-up observations with the Gemini and Magellan telescopes confirmed the discovery. Yes, this really was an asteroid, and there are two particularly curious things about it. First, it's fast, like really fast. In fact, it is the second fastest known asteroid orbit in the solar system. It loops around the Sun once every 128 days. For comparison, Mercury, the closest planet to the Sun, takes 88 days to go around once. Second, its orbit is super rare. This is only the second known object that stays completely inside Venus's orbit. That also puts it in one of the rarest asteroid groups out there, the Asteroids. These are asteroids whose orbits sit entirely inside Earth's orbit. Astronomers have found only a few of them so far, and Scooby is the 39th one in the list. The team of scientists also figured out that this asteroid is pretty big, measuring about 2,300 feet across. That's roughly the size of Merdeka 118, the second tallest building on Earth. If an asteroid this size ever slammed into Earth, it wouldn't just be bad, it would be catastrophic. We're talking about damage on a continental scale. It would blast a huge crater into the ground, then throw out a shockwave powerful enough to wipe out forests and wreck cities. Seismic waves would ripple through the crust, triggering widespread earthquakes around magnitude 7.4, and people could still feel them about 300 miles away from the strike. And that's not all. A brutal air pressure blast would race outward, shattering windows more than 1,000 miles away. Then comes the aftermath. Dust and debris from the impact could shoot up into the atmosphere, block some sunlight, and mess with our climate. I know, you might feel scared right now, but don't worry about it. Thankfully, Scooby isn't going to do anything like that, because it's not on a collision course with Earth. Right now, the math shows it won't be making any close passes by our planet, at least not anytime soon. Still, there's a lot more to learn about this asteroid, but any further studies will have to wait. For now, it has disappeared behind the Sun and is out of sight. Once it reappears, astronomers will take a closer look and try to learn more about what it's made of. That part really matters, because this asteroid is somehow holding up while orbiting so close to the Sun's brutal heat. You see, this asteroid gets very near to the Sun. At its closest point, this asteroid is blasted with almost 6 times Earth's sunlight. At that distance, its surface could heat up to about 440 degrees Fahrenheit. What scientists don't know yet is how a rock this big can get baked over and over again without falling apart. And there are two more things astronomers want to check once it comes back into view: how fast it spins and how bright it looks. Now, by bright, I mean how much sunlight it reflects, because asteroids don't make their own sunlight. They're just big rocky chunks that shine by reflecting sunlight back at us. Anyway, those clues can tell scientists what Scooby is made of. One possibility is that this asteroid is loaded with dense metal, and that could explain how it survives the sun's brutal heat. And if that turns out to be true, this asteroid could be a relic from when the solar system was just forming. Or maybe it slowly moved closer to the sun because the gravity of Venus and Mercury gently pulled on it again and again over millions of years. Now, even though SE79 isn't a real danger to us, and there's still a lot we don't know about it, just finding it is already a big deal. It's a reminder that big asteroids can hide from us. So even in our own cosmic backyard, there are still blind spots where large objects can stay hidden until the right moment of twilight gives them away. And as our detection tech gets better, we keep finding more and more asteroids. By now, scientists have spotted over 1 million in the solar system. They come in all sizes, from monsters like Vesta that measure about 329 miles wide, all the way down to rocks that are smaller than a house. Now, out of all the asteroids we know, about 40,000 are what we call near-Earth asteroids, or NEAs. That just means their orbits bring them close to our neighborhood. Technically, their closest point to the Sun is less than 1.3 times the Earth-Sun distance. It's close enough for planetary defense systems to keep a careful eye on them. And that's exactly why we can relax. I mean, nobody has to lose sleep imagining an asteroid slamming into our planet. Every time scientists discover a new asteroid that comes anywhere near Earth, they track it and run the numbers right away. And then they map out its path years, decades, or even centuries into the future. And they don't do it by guesswork. NASA's automated systems, like Sentry, constantly scan the asteroid catalog and calculate whether any of these objects has even a small chance of hitting Earth over the next 100 years. If something looks risky, it jumps to the top of the watch list and gets followed up fast. So yeah, there are almost 2,000 near-Earth asteroids that technically have some chance of hitting us in the next 100 years. But don't panic. Most are small and harmless, hey, like me. And their odds of impact are usually way under 1%. See why I said we shouldn't stress too much? Cool. Now, sleep tight. Well, the space object 3I Atlas just whipped past the Sun, and instead of clearing things up, the new images made everything even stranger. Because if this thing really is a comet, then it's the strangest comet ever recorded. And if it's not a comet, then we're watching something completely new invade our solar system. So, should we be worried? This all started back in July 2025. Astronomers using the Atlas Survey Telescope in Chile spotted a faint, super fast-moving object, something unlike anything they'd seen before. That was our first look at 3I Atlas, and right away, scientists had a lot of questions. Where did it come from? What's it made of? But more importantly, what is this thing? At first glance, it almost looks like a tiny cell, right? Like something you'd see under a microscope, with a bright center like a nucleus, and this fuzzy outer layer. But when we look at it from a different angle, the mystery clears up. That glow is actually a comet tail. It's precisely because it looks like and behaves like a comet that NASA finally confirmed it. Yup, 3I Atlas really is a comet. The big giveaway is that it has an icy nucleus and a coma, which is that glowing cloud of gas and dust surrounding it. But this comet is a very special one because it didn't come from our own solar system. It came from somewhere else in the Milky Way. And that's ridiculously rare. To give you an idea, We've only ever seen 3 objects like this, period. The first 2 interstellar visits were the famous Oumuamua and the comet Borisov. And now, 3I Atlas. Cool. But you might be asking, how do we know it actually came from outside our solar system? You see, normal comets are bound to the Sun. They swing around it in these big looping orbits. But 3I Atlas isn't doing that. Its crazy speed and path show it's not on a closed orbit around the Sun. And the only logical explanation is that it came from another star system and, just wandered into ours by chance. In other words, this is just a visitor passing through our solar system, and is doing it at a ridiculous speed. When we first spotted it, it was going around 137,000 miles per hour. So this object probably spent millions of years cruising through deep space just to hang around our solar system for a few months. And after this quick visit, it'll vanish into interstellar space, and we'll never see it again. Recently, 2 European Space Agency satellites, along with several NASA spacecraft near Mars, captured new images of 3I Atlas zooming in as it passed the red planet. And one of those images is pretty incredible, showing a cloud of hydrogen atoms around the comet. Scientists were pretty excited about that, as every bit of information we get from this visitor matters. Because the reality is, there are still a lot of unanswered questions about this object, starting with its size. We can't pin it down exactly yet, but NASA says it could be anywhere from about 1,400 feet to around 3.5 miles in diameter. Its exact shape is another mystery, because our telescopes can't really get a clear look at it. The nucleus is buried inside this bright coma of gas and dust, and the sunlight reflecting off all that dust basically blinds us. So for now, we're trying to see it through a bright, dusty fog. If you put all the pieces together, its behavior, its chemistry, and the images we've gotten so far, everything points to 3I Atlas being a comet. But even with all that, there are still some pretty controversial ideas floating around about what it might be. Not long after it was discovered, Harvard astrophysicist Avi Loeb said there's maybe a 30 to 40% chance this object isn't something naturally formed. That comment kicked off a wave of online buzz, with people jumping to wild possibilities. Like maybe it's some kind of extraterrestrial tech, or worse, a threat to Earth. Ooh. According to this theory, 3I Atlas might be a massive extraterrestrial mothership. Its odd trajectory could mean it's sending out little satellites toward Jupiter to collect intel for some extraterrestrial civilization. So, in that version of the story, this isn't just a comet. It's basically advanced space spy tech. But then the obvious question is, why spy on Jupiter, right? I mean, wouldn't Earth be way more interesting to an interstellar civilization? Well, in this theory, Jupiter is the target because it's so much bigger than Earth and the other neighboring planets. The idea that a planet that massive could act kind of as an interstellar beacon, something that stands out from far away. The region near Jupiter is another big reason. It's almost like it's an ideal parking spot, where space technology could basically hang out without using much fuel at all. In other words, if you were going to place advanced satellites somewhere to watch a planet, well, that's prime real estate. Pretty cool, huh? But as fun as that theory is, we gotta come back down to Earth for a second. According to the major space agencies, this thing is a comet, case closed. But that label doesn't make it any less special. 3I Atlas is still a total weirdo in the best way, and it stands out for a bunch of reasons. Let's look at 3 of the most important ones. First, this object is old, like really old. Older than me. Scientists think it's been traveling through space for at least 7 billion years. That's so far back in time that it was formed before our Sun and Earth even existed. So yeah, it's probably the most ancient thing we've ever seen in our cosmic neighborhood. Second, its glow. Comets can sometimes look kinda green, and here's why. When a comet gets closer to the Sun, the ice inside it heats up and starts releasing gas. I know the feeling. Some of that gas is made of carbon-based molecules, especially one called diatomic carbon, or C2. When sunlight hits those molecules, they light up, and to us, that glow shows up as green. But with 3I Atlas, that green color is, well, confusing. The data suggests that this comet is actually low on those carbon chain molecules. So, the big mystery is, if it doesn't have much C2, how is it glowing green at all? Well, nobody knows. And now, the third thing that makes this comet stand out. It seems to be giving off a metal alloy we've basically never seen in nature. So this comet is releasing a plume that contains nickel, that's normal. What's strange is what's missing, iron. In comets, nickel and iron usually show up in pretty similar amounts. Here, we're seeing nickel, but no clear sign of iron. And that's almost unheard of. If the data holds up, it points to an alloy called nickel tetracarbonyl, something we've only ever seen before in human-made industrial processes, not out in space. No other known object has shown this kind of signature. Well, now that you're familiar with 3I Atlas, we gotta answer the biggest question of all. Is it a threat to us? Good news! No, the comet isn't dangerous, and it's going to stay really far from Earth. So we can all take a deep breath. Well, I feel better. Although it's harmless, tracking it has been super valuable for planetary defense. You see, space agencies are always watching asteroids and comets, running the numbers on their orbits, and making sure we'd get a warning if something ever did head our way. But 3I Atlas gave them something new to practice with. This is the first time tracking data from spacecraft orbiting another planet were officially submitted to and accepted by the Minor Planet Center. That's the big global database where asteroid and comet observations get collected and checked, so scientists everywhere can stay on the same page. So, in a way, 3I Atlas was like a rehearsal. Gathering data like this from a totally new setup helps researchers sharpen their methods and improve how we spot future space objects. And that means better detection, faster tracking, and more readiness, just in case the next visitor isn't quite so friendly. Uh-oh.
Did you know that over the past year, around 150 asteroids whizzed closer to Earth than the Moon? But that's not the scary part. It's that some were only noticed after they flew by. And if even one of those had taken a slightly different path, whole cities would be gone. That's what keeps the scientists worried. The invisible stuff, hiding where our telescopes can't see. Let's explore what that means. Astronomers keep a list of asteroids that wander into our neighborhood. If a rock's orbit comes close to Earth, it joins a special club we call Near-Earth Objects, or NEOs. That list can include anything from a harmless little space pebble that wouldn't break a window to a rock big enough to cause an earth-shattering kaboom. NEOs are leftover materials from when the planets were forming. Some of that rubble ended up tucked safely in the asteroid belt between Mars and Jupiter, but some pieces got nudged onto paths that cut across Earth's orbit. Those are the ones we care about, because they're still wandering around today, looping around the sun, and every now and then passing uncomfortably close to us. The biggest objects are the easiest to locate. They are rare and bright enough that they stand out in sky surveys. So far, none of those big ones seem to be heading our way anytime soon. However, the real anxiety comes from the middle class of asteroids. On paper, many of them sit in the potentially hazardous object category, or PHOs, but the nickname City Destroyer explains them better. These rocks aren't huge enough to wipe out the planet, but they could flatten a city and mess with the climate for a few seasons. Some are as wide as a football stadium and hit the atmosphere faster than a speeding projectile. NASA estimates there are around 25,000 near-Earth asteroids at least 460 feet wide, but we've only discovered a fraction of them. Basically, we have solid orbits for less than half of the City Destroyer crowd. The rest only exist as numbers in simulations. We know they should be out there. We just haven't seen them yet. Why are they so hard to spot? Some asteroids are nearly coal black, blending into the cosmic night. Others hang out close to the sun from our perspective, so our telescopes get overwhelmed by brightness. It's like trying to locate a mosquito while staring directly at the sunlight. Please don't do this. From Earth, these rocks are mostly lost in the sun's glare. We only catch a glimpse just after sunset or right before sunrise. And that chance only exists if the sky is perfectly clear and the asteroid happens to be in exactly the right spot. If not, it slips back into the sun's blind spot, playing hide and seek with us. We were caught by surprise quite recently. In 2013, the Chelyabinsk meteor came from the direction of the rising sun. No one saw it in time because it was coming from the wrong direction. It exploded high above the region, shattering windows across the city and sent more than 1,000 people to the hospital. The scariest part is that the meteor was only about 60 feet wide. Now imagine a city destroyer coming from that same direction. A stadium-sized rock stepping out of the sun's glare would give us very little warning, maybe a few days or a week instead of decades. And we know that the blind zone is not empty. Observations have already revealed at least one large asteroid in that region that scientists can seriously consider a planet destroyer. It's called 2022 AP7, and it's huge. This thing is more than half a mile wide, big enough that if it ever hit Earth, it would be a catastrophic day for everyone. Astronomers found it by using the super-sensitive dark energy camera during twilight, pointing the telescope at the region of the sky most surveys normally avoided. The good news is that AP7 isn't headed straight for Earth. Its orbit crosses the orbit of our planet, but the timing doesn't line up, so we won't encounter it this pass, the next one, or even for several centuries. The bad news is what that discovery hints at. If it took this much effort to notice something like this, what else are we missing? And 2022 AP7 is just one PHO. Other asteroids closer to the sun were also spotted during those same twilight searches. New simulations say some of those hidden rocks are not random. A bunch of them seem to share an orbit with Venus. They do not orbit Venus itself. They orbit the sun in almost the same lane, sometimes a bit ahead of the planet, sometimes a bit behind, like kids jogging on the same track but spread out along the lap. Astronomers already know about roughly 20 of those Venus co-orbitals, and their paths are anything but stable. Gravity from Venus, Earth, and other planets keep tugging on them, and over thousands of years, those pulls could stretch their paths until they start crossing Earth's orbit. Most flybys are harmless, but one unlucky pass could be the one that counts. So what can we do about this? The first step is simple in theory. Find them earlier. The goal for astronomers is to launch infrared telescopes and get them into space. While we do have amazing telescopes like JWST or the Hubble Space Telescope, they're never pointed at the sun, as the brightness of our star can damage them. That's why we need a telescope in orbit around Venus, or one that travels along with it. It would be in a much better spot to keep an eye on the asteroids that hang out there. NASA is launching the NEO Surveyor project that aims to solve the problem. It should scan the inner solar system to spot dangerous asteroids in time. Also, we're learning that we can actually move asteroids. NASA's DART mission rammed a small spacecraft into a rock, which affected its orbit slightly. Not by much, just enough to prove that it can be done. It's like turning a plane just 1 degree while it's still across the ocean. By the time it reaches you, that tiny change can make it miss by thousands of miles. Teams around the world spend their days babysitting space rocks, and yes, that's a real paying job. NASA has the Planetary Defense Coordination Office. Europe has the NEO Coordination Center. Observatories feed them nightly sky data, and computers immediately check each dot's orbit. If a rock might wander too close, it joins the risk list and gets extra attention. Each new photo updates the orbit a little more. Sometimes that make the danger level rise for a moment. That is exactly what happened with 2024 YR4, when it briefly reached level 3 on the Torino scale before better measurements calmed everyone down. The scale itself runs from 0 to 10, and anything that climbs above 3 is rare enough to raise eyebrows. The whole system works that way on purpose. Notice something strange, collect more data, then decide whether to relax or stay alert. Most of the job is actually pretty dull. It's a lot of number checking, orbit fixing, and crossing out false alarms. That quiet, careful routine is what lets the world respond quickly when a rock finally appears that isn't just passing by. So how worried should we be? For those huge planet-destroying rocks, the short answer is not much. Nothing that size is on the near-term schedule. Smaller city-level threats are trickier. The odds of one hitting Earth anytime soon are still tiny, but they're not zero. Think of it as a cosmic lottery that has been running for billions of years. Every once in a very long while, the universe draws a number that makes astronomers sit up and pay attention. It's not a reason to panic. It's a reason to build better eyes in space and make sure that if a bad ticket ever comes up, we see it in time to do something about it.
Hey, can you lift a truck with your hands? No? Shocker. But let me introduce you to nature's original strongman, the ocean, which casually tossed 700-ton boulders around like they were pebbles during a mega tsunami that hit Africa thousands of years ago. This wasn't just a bad day at the beach. This mega tsunami was so powerful, it made the 2004 Indonesian and 2011 Japanese tsunamis look like kiddie pool splashes. Now, to give you an idea of how terrifying regular tsunamis already are, the Japan tsunami produced waves 133 feet tall. The Indian Ocean tsunami was slightly smaller, but it took over 200,000 lives across many countries. Now, imagine something way worse. You see, for a long time, scientists thought waves that big were just science fiction. But then they found these enormous boulders, massive chunks of rock, flung far inland, and did the math. It turns out only waves around 800 feet tall could have pulled off that kind of rocky vandalism. And the culprit? A volcano that literally fell apart into the ocean and triggered one of the most powerful tsunamis Earth has ever seen. Usually, tsunamis are blamed on underwater earthquakes, tectonic plates getting into slap fights. But volcanoes? Oh, they've got tsunami potential too. In 1883, for example, a volcano in Indonesia named Krakatoa erupted for 6 months non-stop until it exploded, and the explosion was heard all the way in Australia. This triggered many tsunamis, some almost 100 feet tall. Still, that was more like a toe dip compared to the full cannonball from the mega tsunami. Back in ancient times, the volcano that crumbled during the mega tsunami was huge, and it didn't just fall apart. It lost a chunk that was 10 times the size of Mount Everest. 10 Mount Everests. It was like the Earth wanted to see what would happen if we threw a mountain into the ocean just for fun. It was so massive that when the entire side of the volcano belly flopped into the Atlantic, it created waves that could cover the Statue of Liberty 3 times. It also destroyed an island more than 30 miles away. The volcano behind this real-life Michael Bay scene was called Fogo, located on, you guessed it, Fogo Island. This island is basically just a whole single volcano that rose from the sea thanks to a magma hotspot, a place in the ocean where a lot of magma escapes and erupts like an underwater volcano. Over time, this magma cooled and stacked up like pancakes until, voila, after 7 major eruptions, the island popped out of the ocean like it was playing peekaboo. Surprise, it's a volcano. But Fogo's dramatic entrance was also a ticking time bomb. You see, the more a volcano grows, the heavier it gets, and if there's not enough magma inside it to support it, the whole thing can just collapse. Sometimes it doesn't take much. A minor earthquake, some erosion, or just a poor foundation made of soft sediment can trigger a collapse. It's like a really tall guy trying to balance over a bunch of marbles. Fogo had all the bad luck ingredients. too tall, too heavy, and built on squishy ground. And it gets worse. As the volcano grows heavier, it starts squishing the magma underneath. That lava can't rise, so it just simmers down there, slowly thickening like soup left on a burner for too long. Gases build up, pressure increases, and eventually, kaboom! It's the volcanic version of eating too many burritos and then trying to hold in a sneeze. This massive pressure and imbalance can trigger what's called a flank collapse, which is science speak for oops, half the volcano just fell into the ocean. That's what happened with Fogo. Most of the volcanic islands that form this way are long gone, but Fogo is still very much alive and kicking. In fact, it last erupted in 2014, and considering that it goes off every 20 years, maybe don't travel to Fogo Island in around 2034. For the longest time, scientists believe only big, bulky volcanic islands could collapse like this. But new research says that even smaller, skinnier guys, like the Danny DeVitos of the island world, aren't safe either. The thing is that small volcanic islands only seem stable because of their small mass. It's like Danny DeVito and Arnold Schwarzenegger both slipping on the ice. Arnie's fall might cause more chaos, but Danny can still go flying. And those little collapses? Yes, they matter. Take Santa Maria, a tiny island that's about 170 times smaller than Hawaii. It has collapsed multiple times, not because it wanted to, but because it's basically standing on soggy breadcrumbs. Its foundation is loose marine sediment, and to make things worse, it's sitting right next to the East Azores Fault, where 3 tectonic plates meet up for daily slap fights. This fault is responsible for many earthquakes and even some tsunamis that happened in Lisbon in the past, so you can imagine what it's like living right above it. Every time the volcano in Santa Maria erupts and grows, it also sinks. But when a chunk collapses, it bounces back up like a buoy. This seamount to island again roller coaster means that Santa Maria has popped in and out of the ocean like a submarine playing peekaboo. And with every peak comes a potential tsunami. Another volcano with similar trust issues is Pacaya, located in Guatemala. Between 2011 and 2013, scientists spotted strange movements in the soil, tiny shifts that suggested something underneath was getting restless. Sure enough, in 2014, Pacaya erupted. Luckily, it didn't collapse, but that risk still looms, especially if magma gets trapped in it like it did with Fogo. The consequences could be explosive, literally. In fact, about 1,000 years ago, Pacaya experienced a collapse that sent debris avalanches more than 15 miles away. Since then, it's rebuilt itself like a fiery phoenix, but it could still crumble again. That's why volcanologists obsess over the tiniest wobbles. It's not paranoia if the mountain really might fall. Now you might be thinking here, okay, but that was the past. Surely that kind of ridiculous mega tsunami collapse can't happen again, right? Well, welcome to the 21st century. Islands like Hawaii, La Palma in Spain, and various parts of the Caribbean are sitting on the same kind of geological whoopee cushions. All it takes is the right combo: loose foundation, steep slopes, maybe some trapped magma, and boom, flank collapse. In fact, it's already happened recently. In 2018, Anak Krakatau, the volcanic baby of the infamous Krakatoa, lost a big chunk of itself during an eruption. It caused a tsunami, but it was more awkward than devastating, like a volcano losing its pants on stage. Embarrassing, but survivable. But that's just amateur hour compared to history's real showstoppers. Ritter Island's 1888 collapse was so intense that the island literally got shorter. It went from being more than 2,000 feet tall to a mere 460 feet. But the record holder is the legendary Latua Bay megasplash from 1958, where a 7.8 magnitude earthquake triggered a massive landslide that sent a wave taller than the Empire State Building roaring through Alaska at highway speeds. Strangely enough, only 5 people lost their lives here, but on the other hand, the destruction path it left behind can still be seen today, all the way from space. Melting glaciers and ice caps can make volcanoes collapse too. When they melt, there's a sudden decrease in pressure on Earth's crust that can destabilize entire volcanoes. It's called isostatic rebound. It's like suddenly yanking a chair out from under someone who's been sitting still for centuries. Whoops. Also, here's something you probably never thought you'd worry about on your island getaway. Some volcanic islands grow outward as lava pours into the sea, creating unstable platforms known as lava deltas. These deltas can collapse without warning, taking newly formed land, and sometimes tourists too, right back into the ocean. No pressure though, just thought, maybe you want to stay off steaming new land. So yeah, next time you're lounging on a beachy volcanic island thinking, wow, this place is paradise. Just remember, it might also be a ticking geological time bomb with a flair for the dramatic. From ancient mountain-sized cannonballs to surprise lava deltas, volcanoes have a history of keeping things spicy. Oh boy, scientists predict a volcanic eruption that is likely to be one of the most destructive in the history of our species. There's a 1 in 6 chance of it happening in this century, and it could seriously change the climate even more and put millions of lives in danger. Back in January 2022, the Hunga Tonga Hunga Ha'apai volcano erupted in the South Pacific Ocean, creating a huge explosion. It sent tsunamis all the way to Japan, North America, and South America. Tonga itself was hit hard, with damage costing nearly 20% of the country's entire economy. Now, researchers at the Niels Bohr Institute in Copenhagen have studied ice samples from Greenland and Antarctica, and their findings are worrying, predicting potential global volcanic disaster. They say there's a real chance of a much bigger eruption, a whopping 10 to 100 times larger than Tonga's. In the past, eruptions this size used to change the climate and even cause civilizations to collapse. Despite future volcanic eruption risks, experts say the world isn't prepared at all. Michael Cassidy, a volcanologist from the University of Birmingham, warns that no sufficient effort is made to handle a disaster like this. He says that NASA and other space agencies spend billions on asteroid defense. At the same time, a volcanic supereruption is way more likely than an asteroid impact. And right now, there's no global plan for dealing with a massive eruption, even though it's likely to be far more destructive. The last magnitude 7 eruption happened in 1815 at Mount Tambora in Indonesia. Then, thousands of people lost their lives in just a few days. The disaster also disrupted weather and caused food shortages worldwide, affecting millions. That eruption was the biggest in recorded history. It blasted a massive cloud of particles into the sky. Those particles blocked sunlight, cooled the planet, and caused worldwide chaos. The year after the eruption became known as the Year Without a Summer. Temperatures plummeted, crops failed, famine spread, and a cholera pandemic broke out, leading to tens of thousands of lost lives. A shocking fact, the eruption may have even inspired Mary Shelley to write Frankenstein while stuck indoors during the unusually cold summer of 1816 in Switzerland. Now since then, many volcanoes have erupted, but none have matched Tambora's scale. Now, over 200 years later, scientists warn that there's a new supervolcano threat. Another massive eruption could be on the way, and the world might not be ready for it. So, while scientists seriously discuss the likelihood of the next volcanic eruption, experts are calling for urgent action to prepare before it's too late. So the thing is, a massive volcanic eruption today could be even more devastating than the Year Without a Summer. Unlike back then, we're already dealing with all kinds of weather changes and a more fragile global system, which could make the effects even worse. Dr. Michael Rampino, a geological scientist, warns that the world is more unstable now, and it means that a modern-day mega-eruption could have even more severe consequences. But this time, greenhouse gases from fossil fuels may make the aftermath of such an eruption even colder instead of warmer. So we're talking about volcanic activity endangering humanity. Dr. Thomas Aubrey, a volcanologist, found that in a hotter, more turbulent atmosphere, the sulfur dioxide gas released by a volcanic eruption would spread faster and farther than in the past. This gas forms sulfate aerosols, which reflect sunlight and cause global cooling. Because these tiny particles would be more evenly distributed, they'd have a stronger cooling effect than in 1815. Another atmospheric scientist at Cambridge explains that the size of these airborne particles matters. It affects how they absorb sunlight, and in a future warmer climate, an eruption could make the surface cooling stronger by 15%. At the same time, there are still many unknowns. Scientists from the University of Geneva say that we're only beginning to understand the full impacts of such an event. It's also difficult to precisely estimate future volcanic eruption risks, since we have very little data on older eruptions. So, to understand past volcanic activity, researchers analyze ice cores from Greenland and Antarctica, as well as ancient tree rings. Those act as historical records of weather changes. These measurements suggest that several eruptions in the past few thousand years temporarily cooled the planet by about 2 to 2.5 degrees Fahrenheit. One of the most catastrophic examples is the 1257 Somalis eruption in Indonesia, which was so powerful that it likely triggered the Little Ice Age. It was a period of global cooling that lasted for hundreds of years. More recently, the 1991 Mount Pinatubo eruption in the Philippines slightly cooled Earth for a few years. Because this eruption happened in the satellite era, scientists were able to measure exactly how much sulfur dioxide was released and how it affected the atmosphere. But even with modern tools like satellites and seismic instruments, scientists still have difficult times forecasting the next big volcanic eruption. Luckily, even though we can't predict the exact timing, we can study worst-case scenarios to help authorities prepare. This includes creating evacuation plans and stockpiling food in case of global crop failures caused by volcanic cooling. The changes in weather patterns might make volcanoes more active. Melting glaciers can reduce pressure on underground magma, which will increase the chances of an eruption. Plus, more extreme rainfall, which is becoming more and more common, can seep into volcanic cracks and cause powerful steam-driven explosions. It can affect both active and dormant volcanoes. Because of these risks, researchers are now mapping volcanoes that are the most vulnerable to climate change. Their studies show that the highest supervolcano threat comes from such areas as Iceland, Chile, and Indonesia. Those are places where glaciers are melting quickly or rainfall is increasing dramatically. A 2022 study found that 716 volcanoes worldwide, that's about 58% of all known active above-ground volcanoes, could be triggered by extreme rainfall, increasing the likelihood of another mini ice age. Now let's get back to that Hunga Tonga Hunga Ha'apai eruption that occurred on January 15, 2022. Scientists have confirmed that it created the highest plume ever recorded. The volcano, located underwater in the South Pacific, sent an ash cloud 187,000 feet high. That's higher than any previously recorded eruption. What makes this eruption even more remarkable is that it was the first to ever reach the mesosphere. It's the third layer of Earth's atmosphere. The mesosphere begins at about 160,000 feet above Earth, where meteors start burning up and creating shooting stars. To measure the plume's height, researchers from the University of Oxford and RAL Space used data from 3 geostationary weather satellites. Before this, the record for the highest volcanic plume was held by Mount Pinatubo's 1991 eruption in the Philippines, which reached 131,000 feet high. Interestingly, this kind of measurement was only possible thanks to modern satellite technology, and a decade ago, no one would have been able to do this. Another volcano we should mention in relation to a potential global volcanic disaster is located on Iceland's Reykjanes Peninsula. Its latest eruption happened in November of 2024, leading to evacuations in nearby areas. The eruption began just after 11 p.m. with little warning. The volcano released orange lava from a nearly 2-mile-long fissure. Authorities ordered evacuations for about 50 homes and guests staying at the Blue Lagoon Spa Resort, a popular tourist destination southwest of Reykjavik. While air travel was not affected, officials still warned of potentially dangerous gas emissions spreading across parts of the peninsula, including the nearby town of Grindavik. Grindavik, home to 3,800 residents, has repeatedly witnessed volcanic activity, and past eruptions even damaged its infrastructure and forced evacuations. For example, in August 2024, a 2.5-mile-long crack opened at the Sundhunkangigar crater near Grindavik. It led authorities declaring a state of emergency as lava flowed in multiple directions. Fortunately, Iceland's meteorological office reported that the latest eruption was significantly smaller than the one in August. Geophysics experts conducted aerial surveys and figured out that the situation appeared less intense than the previous eruptions. These days, Grindavik is not at risk, but the possibility of further developments cannot be ruled out. Scientists predict more volcanic eruptions. That's it for today. So hey, if you pacified your curiosity, then give the video a like and share it with your friends. Or if you want more, just click on these videos and stay on the bright side.